Good evening, y'all. Welcome back to another Sunday night shenanigans and electronics and servo motors and LEDs and stuff. Whatever these Sunday nights are. They're not really electronics bashes. They're just fun times with fun people. Who's here? Oh, hi, Thomas. Hi, Chris. Dave is back. Dave, thank you. Hello. Good to see you again. Yeah, it's just another Sunday night. Welcome back. We are in sweater weather here in Chicago. It was 12 degrees over the weekend, and then it was 45 degrees today, and we're just having a time. So wherever y'all are geographically for the holidays, I hope you are staying warm and or cool. Some of you are out west where it's actually warm. Hey, Nate, good to see you. Thomas, Thomas messaged me after we did the Fusion 360 intro last time, which was miraculously crash-free, saying that his had crashed immediately thereafter or during. So, and it sounds like had 4 crashes today already. So maybe Thomas, I apologize if my good karma is somehow shunting lots of bad Fusion karma to you. It wasn't my intention, but thank you for taking one for the Tiny Moving Light team, I guess. Yeah, thanks. That is more my experience. I've had really good luck recently. I don't know what that's about. I've changed nothing, but here we are. Yeah, here to work on more Tiny Moving Light stuff. What does Chris say? Oh, those assembly. Oh, Chris, they are not assembly instructions. They are actually This was if you were here for the Fusion 360 instructions last week, I sort of teased that there was cool Demilight news that I couldn't talk about till after the holidays, and that's because I had a friend or a friend's partner, two friends who are partners, who's the partner bought a Demilight off of me for her partner for Christmas. And so this was it blew my mind because the point of these is not really to sell them. It was make a cool project that other people could also make and maybe sell the circuit boards just because to my mind is the easiest way to get them out there, just because it's a slightly advanced skill, like ordering circuit boards from a fab, even with all the files provided. But this was really cool. She reached out and said, hey, my husband's a big old nerd. This is a little bit dark, yeah? What is that about? Let me see. Here, hang on. You get a moment of tummy cam as I stand up to adjust this thing, because we can fix this. Let's just overexpose ourselves a little bit there. There we go. That looks a little better to me. Hopefully it's not too blown out. But so as part of selling off, I was one of these, the blue and red model 0.9.4 models. I was like, well, I should probably include some instructions so that this guy knows what he's getting into. And so I made a little front and back sided Demilight Model A spec sheet, which was super fun. I had a really good time doing it. I got to use Fusion 360. We looked at this incredibly briefly last time, but it will do technical drawings basically for you out of your assemblies. So I did the wireframe drawing and then snipped that out and put it on here. Gave a little view of what the plugs on the connector are. Some notes on the fact that it's not currently readdressable unless you reflash the firmware. But I got a delightful video from this friend Christmas morning saying, look at my big nerd of a partner who is just playing with this thing, terrifying dogs with it. So it turns out that the noise of the stepper motor is not something that every dog loves, and one of their dogs, Goose, who has big long legs, was just absolutely terrified of the thing. I know, Chris, right? I had such a fun time. It sent me down a little bit of a rabbit hole, and we'll get to the content of what we're actually going to work on tonight. But I've been working on the workshop a little bit over the past few weeks, as y'all have seen. And there's a couple of new things that I want to talk about too. But one of the things that I did, so as part of working on the Tiny Moving Light and other related projects, I did things like print and organize the relevant ESTA standards into a bunch of thematically appropriate binders. So ESTA, for those who don't know, is they've changed names a couple of times. They were ESTA Plaza, then sort of split again. But they're the organization that writes the standard for what is DMX, what is RDM, and all that kind of stuff. So I find it kind of a little bit of a pain to navigate these standards on the internet. It's partially just because so this is ESTA 1.20. This is what RDM is, that protocol that you know, allows you to configure devices or receive feedback from them over a DMX network. And, you know, there's a fair amount of detail in this standard, and a lot of it is just like what the structure of various message types is. So, like, for example, just to pick a page at random, you know, the RDM standard has an idea of here's a device I'm communicating with that might have sub-devices within it. The sort of classic example being like a dimmer rack, which might have one controller and one DMX port and dozens of individual dimmers that have their own settings that you might want to configure individually. And so it tells you, like, okay, to send a get or set sub-device status reporting threshold parameter, this is the kind of message you would send, and so on. There's just so much information here, and I find it really hard to absorb it online. So I went ahead and like printed it all out, and organized it for myself. This all to say, what does this have to do with giving a friend this, you know, the little one sheet? Well, I think it's actually in this binder, which is sitting on a new set of shelves back here that's not permanent. It was just free in the alley, so I took it because I always need more storage. Yeah, the wireframe drawings are just like, oh yeah, they just feel so good, right? This was a fun one. This was a 3D model. We might have done this in the Demilight, in the Fusion 360 stream, pulling a model in. This was one I downloaded of my Phoenix connectors from DigiKey. So I just pulled the 3D model into CAD and then had it spit out a drawing for me. That's pretty cool. So anyway, what started me on this like runway of printing off and organizing all these standards was there was an ESTA standard. Actually, there's several for if you're selling, which I'm not, but if one was to sell a lighting device, what is the photometric data, the lighting data that they encourage you to publish, and for some devices, how do you measure it? Right, so this is standard E1.9, originally from 2007, and this tells you. So you may have seen a diagram like this if you're listen. I know you're all nerds. I know some of you are lighting humans. I know the rest of you are all big old nerds. So let me a little bit of context for those who have not been staring at lighting diagrams. When you buy a theatrical lighting fixture, you will often get an illuminance diagram. This one's of course rotated, much like this, that tells you, you know, this is the brightest point in the light, and then at what degree off angle does the light sort of drop off in intensity from center. And there are various ways that like manufacturers and manufacturing groups have specified, you know, the beam angle and the field angle are terms that you hear a lot in lighting design, which are the points at which the light drops to, you know, depending on who's defining it, like 90 and 50% of the intensity, or sometimes 80 and 50%. And so this document talks about like what the definition of all those things is and how you would go about measuring them in some standard terminology. So I was like, this would be fun if I'm making a little fake data sheet. It's not a fake data sheet, it's a real data sheet. It's just like, it's mostly for fun. What information am I supposed to put in it? And that sent me down a rabbit hole, because what I didn't know is, in addition to E1.9, the photometrics data, there are, of course, ESTA standards for how you measure illuminance of stage luminaires. Like, how do you actually measure what the lumens output of a light is, and how do you calibrate your photometer so that you all get consistent results. Then there's a whole other standard, E141, which I really haven't gotten into very deeply yet, which is how do you measure illuminance from what they call a solid state light source, I think. Let's see here. Yeah, a solid state light source, aka LEDs, right? Because a lot of classical light meters assume that you have a spectrum curve that looks a lot like a tungsten lamp. And so if you start throwing LEDs at it that have very specific peaks and valleys in their output, it may or may not reflect a luminance value that corresponds to how bright the human eye thinks something is. So this is the E141 is the standard for the sort of human eye model of how an LED light appears, and sort of standards for, with respect to various reference colors, how you sort of determine what would be equivalent to CRI. CRI is kind of a, the consumer term for how close an LED light is to truly white light. But so you might have bought a bulb that's 80 CRI or 90 CRI or 95 CRI. But that doesn't really capture all the different ways that a light could be different from a white light. It just tells you sort of how close or how far. And so some of these standards and some of this document spells out some specific application information, talk a little bit more in detail how you can tell, how you can describe the qualities of an LED light and how, maybe the light is very close to a tungsten black body curve in the red-green part of the spectrum, but maybe it's not particularly good at rendering in the red-orange part of the spectrum. So anyway, so I went down a complete rabbit hole and did some printing out of documents and things and organized some parts of my shop to have those standards readily available, especially as I'm still trying to get the Demilight to speak RDM so I could, configure it over a network without having to reprogram it every time. Nate asks, oh yeah, what's the phone number in the corner? Yeah, so that was my fun holiday gift to myself, or one of a couple, I guess. That phone number, 815-662-5678, or in telephone words, 815-0-Malort. That's this phone right here. Which, let's see, I might have to cast a little more light on it for the camera to focus. This is an old AT&T Bell telephone that's a rotary dial phone that I took home from work to play with while we're sort of on hiatus there. And it genuinely works. I got a device called an ATA, an analog telephone adapter, that basically this is plugged into a little box that's plugged into my Ethernet switch. And so I can actually make and receive phone calls. It actually has, if the, you might be able to hear, it has a dial tone. You might not, it's pretty quiet. You may not be able to hear that on the lav. But in I have no particular purpose for it. It just tickles me to have a rotary telephone in my workshop. So I've actually talked to a handful of people already, just picking up the phone and calling them. A couple of them were the nerds who inspired me to get a rotary phone in the first place. But I don't know why the number is there or why anyone would call. I mean, if I forget to unmute myself again and I just am not paying attention, you can call the phone. It has the telephone ring. It has two bells in the base here, and you're not gonna be able to see this, I think, but down here at the bottom, there's a little lever just here that actually is moving one of the bells inside that case closer or farther to the clapper to make it louder or softer when it rings. Yeah, it just amuses me. So I don't know. I put the phone number there. If you have comments or concerns, feel free to call at any time. It's what's interesting, and I know we have a range of generations of people here, which is really cool. I'm a millennial, I think, in the classical sense. I don't talk on the phone all that much, and just picking up the phone and calling someone, especially on an analog phone, is actually really pleasant. I wasn't expecting it to be. I thought this was going to be a put it up and then I don't know. No, it's actually just really nice to make and receive phone calls. So yeah, I don't know. That's what that's doing there. Call or don't, or anytime. It's set to not ring late hours or early mornings, so you can't wake me up in the middle of the night with a phone call, if anyone was thinking that. But yeah, that's what we got. When Jeff gets in a long tangent, yeah, you can call it to distract. You can call it to bring me back to topic. All kinds of fun things. So that's what that is. That's just a toy that I brought home. I now have acquired a few other phones. There's also something delightful. I swear we're going to talk about tiny moving lights, but I rescued from the dumpster at one point one of these, an actual business line phone, and my phone adapter has two ports on it. The idea of having this phone and the rotary phone sort of sitting next to each other and maybe being on different extensions of the same, it just tickles me. It's just fun, and we can all use a little bit of fun right now, huh? It's just it's a beautiful phone too. It's an actual red emergency phone that was used. It's stamped on the back. Property of Bell Systems do not sell, from the time when your phone was owned by the phone company, and you didn't own any of your own devices. Anyway, that's what that phone number is, because it makes me laugh. Yeah, I think that's all. I mean, there's more workshop news, but when it's done. Shall we do some tiny moving lighty stuff? I think we should. I think we should get into it. Seems like the Demilight site is broken. It's only the STLs and Gerber's zip didn't have more for... Ooh, that's good to know. Stand by. I guess if it's broken, I don't want to like put it up on the screen, but you can listen to my melodious voice here. Jeff.glass/Demilight. I guess you can see it until I... Ooh, yeah, that's very broken. Well, there's the STLs, if anyone wants to go and download them. Those are not supposed to be live. Why is that... Oh, I know what I've done. Yes, so what's happened there is Jeff.glass/Demilight redirects to a page within WordPress. You don't get to see the admin interface of my WordPress page, but I'm still here. But I don't have a way to just show you my face from the comp cam. What's happening there is I created a page to work on the Demilight instructions, and then I created a redirect on my web hosting service to point. Let's see, how have I screwed this up? Oh, I made a folder under Jeff.glass called Demilight to hold those files, and so of course it is defaulting to sending you to that folder instead of the page that I meant to. So this should be a relatively quick page, and then we can look at something more interesting than like bags of Neopixels. Let's see. Let's rename that, and hopefully that just fixes it. Yes, all right, it's at least fixed on my end. I have removed that conflict. Wow, probably should have checked that, huh? So now if you go to, hey, there's my face. Now if you go to Jeff.glass/Demilight, now you should have all of the information there. I've hidden those files. So if you downloaded those files in the last 2 minutes, congratulations, you're the first folks to have them. They're not supposed to be released until, I might as well talk about this now that I've spoiled it a little bit. My stated goal is to have those files, which were sneakily on the internet there for a little bit, available by the time we do the next Demilight stream in 2 weeks. So January 10th, I think it is. And that's just because I need to draw a line in the sand for myself, or I'm just going to keep fiddling with these forever and never releasing them. They're good enough. They don't catch fire. The 3D prints basically work. The design is okay. So I'm going to put them out there by January 10th. And so probably when we come back in January, 2 weeks from now, maybe that night will be about like just walking through the assembly of one using the instructions on the website. And if you want to look, I'll try and get the files up a couple days before that in case you want to get a head start. If it's going to just like, it's going to be at least a base layer of how to put the thing together, and probably there'll be things that don't make sense, and it'd be great to get some live feedback on that as they come out. So that's what's going on with those. Thomas says, if only big beefy LEDs were as easy to drive as those Neopixels. Yeah, no, for sure. That's going to be one of the joys of tonight, is like so much of what's going on these circuit boards is extraneous if you're doing a Neopixel solution. So I think we should have a good time tonight. So thank you, Thomas, for tastefully bringing us back to the point. So what are Neopixels, and why would you want them in a tiny moving light? So this is a circuit board, as you might have guessed, that has 7. If Murakami came, I'm gonna reduce. Now that we're not looking at documents anymore, I can turn the exposure back down. You can see this black PCB a little bit better. Yeah, that's much better. Let's see. These are 7, specifically WS2812 Neopixels. So they are RGB. These might be RGB W, actually, now that I come to think of it, which will complicate things just a little. They're either RGB. Oh, yeah, they're RGB. I don't know. We'll find out when we hook them up. They are 50/50 LEDs, right? So 50, I guess 5mm by 5mm along each side, that have an red, a green, and a blue LED inside them, as well as a tiny driver chip. And you can see the little dot on there. That's a little silicon die that is the controller that controls those RGB pixels when you send them data. And what does that mean? Well, I pulled up a few useful bits of information here. So one thing to know is that Neopixels is Adafruit's name for the WS2812 chip, as well as some related ones. They took the WS2812 from WorldStar and branded it Neopixel, which is a catchier name for sure. So I often just say Neopixel, WS2812, same exact thing. The way that you would wire up a WS2812 set of LEDs is each LED, and I think I have a datasheet downloaded here somewhere. Maybe I'll just pull up the datasheet to start. So prepared, Jeff. Thank you. Yes, I know. Very good. So the WS2812, yeah, this will be a good place to start, it's got 6 pads, right? It's got power in, it's got ground, right? Those are not terribly exciting. It's got data in and data out. So what you do is you feed a SPI-like data, a single wire data protocol, into the input that communicates the levels of the brightnesses of the LEDs that you want them to be at, and then it spits some data out its output. And the clever thing is that if you feed in, say, the data for 20 LEDs into a single LED, it will take the first frame, the first chunk of information off the front, and only spit out the remaining 19 LEDs worth of information. So the next LED in line can take its data input from the data output pin on the first chip. It will only read the first frame and then, say, transmit the next 18 frames, and the next 17 frames, and the next... So basically, with a single line of data, you can be driving, many, dozens or hundreds of LEDs with a single data output line. Much easier, as Thomas sort of mentioned there, like it's much easier than having an individual RGB driver chip that has to be individually controlled and addressable and PWM and all that. You just need one data line, and you sort of pass it serially through all of your chips. That's the gist of it. Now, the timing requirements on that one-wire protocol are fairly tight, and that'll be one of the things that I'm interested to see tonight as we start to sort of integrate that with a Demilight code base. So you can see down here, for example, every 1 and 0 is represented by either a short high pulse and a long low pulse, or a long high pulse and a short low pulse. And the data frames are essentially, so you get 8 bits of green data, 8 bits of red data, 8 bits of blue data. So you get basically RGB dimming in 8 bits. And you wire your connections. Here's what I was trying to explain with words. You wire the data out of one chip into the data in of the next chip, and it automatically handles sort of lopping off, if you will, the first frame, the first 24 bits of information, and then it passes on the rest of the information down the line. Oh, let's see. A strand of 2811 LEDs. Oh, yes. So let's talk a little bit about. Francisco. I am on Facebook. I think my Facebook is mostly private and personal. I don't have Demilight stuff on there. But you find me on Twitter or call me. I think I may be international. I don't know how a rotary phone does the international calls. But yeah, feel free to hit me up on any of those platforms or here anytime. Yeah, maybe when the thing is released, I'll make a Demilight Facebook page. It'd be fun. Or just ask Thomas. He's a smart guy too. Just to briefly note, because Thomas mentioned the WS2811. There we go. So there are various species of this same idea of controller, this idea that you have a chip often built into a little LED package that takes data in, takes some data for itself, and spits some data out. The WS2811 was the first one that came around, and in that form factor, I actually don't think I pulled up a picture of it. What you see is the WS2811 was actually a separate chip. So if you have some, say, LED tape that is controlled by WS2811s, you would see LEDs, this is just a super bright LED, some LEDs that are sitting next to an 8-pin IC that's controlling it. Starting with the WS2812, they basically took the die inside that IC and stuffed it inside the 5050 LED package, just for compactness reasons. So, and they changed the timing requirements slightly. In theory, most of the time I find the WS2812 timing works pretty well on the 2811s, but there is some variety out there. The other varieties of sort of addressable pixels, Chris asks, is that the only difference between the 2811 and the 2812? I think so. Let's see if we can get the 2811 data sheet. Nominally, so when it was released, the press around the 2812 was that it was the 2811 die inside the 5050 LED package. Let's see if that is true. Okay, so the 2811 has this set pin. Yeah, so you'll see, and when we get into permitting this on the library, you'll see that you often get a choice between a 400 kilohertz signal or an 800 kilohertz signal. I don't think on the 2812s you get the option. I think it's only 800 kilohertz. But apparently this set pin on the 2011, you can pull high or low to configure which of those ones you want. And then of course that you have to have external outputs, red, green, blue, to hook up to external LEDs. So yeah, so like instead of having these LEDs built into the chip, so to speak, they would be built into the same package. Thomas points out, oh yeah, so because you have because your LEDs are being driven externally, you can drive these outputs, I guess the anodes of the LEDs with a higher, the cathodes of the LEDs with a higher voltage. I don't know what the cap on it is. Thomas says they're often running directly at 12 volts. I would believe that, although I think the data is still 5 volts, yeah? Let's see. Voltage in, high, low, 0.7, 0.3. Yeah, so I think if VDD is their voltage input pin, yeah, so, oh, actually, maybe you can run it up to voltage high level, minimum of 0.7. So maybe if you run these at 12 volts, can you, let's see, power supply voltage. Here we go. So you have to power the chips with 6 to 7 volts. They can drive 12 volt LEDs on their output pins. That's how I'm reading this data sheet, at least. But don't quote me on that. Data is 5. So let's see, Thomas says data is 5, LEDs controlled in groups of 3. Yeah, and that's probably just for forward voltage reasons. Like even in their sample set here, they illustrate them with having 3 LEDs, just because you have less power loss in your current limiting resistors. Although in theory you could run them at 5 volts like they do down here, which is interesting. I don't use 2811 strips all that much, I'll be totally honest, just because it's so convenient and like cleaner to have them in 2812. The 2813 and the 2818, just to mention, and I have data sheets for them up here. The 2813 is like the 2812, it's all built into one LED. The 2818 is like the 2811, it's a separate chip, but both of them have a redundant data line. So that basically, and this picture from Seed Studio, it sort of sums it up. If you have a single LED die, due to heat or poor manufacturing or what have you, the data passes through it on this redundant data line, so it won't kill the rest of your string necessarily if one individual pixel dies. Obviously, if you have mechanical faults, like if you cut your line in half, it's not going to pass that signal anymore, but the 2813 and the 2818 both have this redundant data line feature. The 2815, just to mention, as long as we're covering all this ground, is a slightly different beast. What was the? And I'm to be perfectly honest, I'm not remembering why the 2815 is different, even though I looked it up earlier today. 2815, is like the 2818, in that it has dual signal wires as well. Let's see. Thomas says, I don't find your profile on Facebook. Is there a particular image? Oh, you might have to look for Jeff Glass. The picture is my face, so hopefully, I'm looking pretty good in the suit in that picture if memory serves, but let's see, Thomas says 2811s, are nice for long strips. Yeah, so because you have sort of 3 LEDs per chunk of control, you can do things like Thomas says that are, if you need more length and less resolution, so to speak, and you don't have a controller that will do that chunking for you, you can use 2811s. We did the same for a production of Christmas Carol that had a bunch of LEDs in the background. Yeah, and running power into both ends is a pro strat, as it were, for making sure you don't have voltage drop across the length of your chain, for sure. The one last thing I want to mention, and then I swear we're going to build some tiny moving light stuff, but context is key, is to talk just a moment about dot stars and APA 102. So again, APA 102, or SK 9822, I think, or 9822.3, those are numbers, are what Adafruit has rebranded as the dot star LEDs. And it's a very similar idea, right? It's a controller built into an RGB LED package, but it has a slightly different control philosophy, where the World Semi chips, the WS chips, and the SK6812s, all the ones that cloned World Semi, have a single data line that runs at has to run at a very specific frequency, or the 2011 light we saw, one of two specific frequencies. The dot stars, the APA 102s, is a clocked protocol. So you need two data lines instead of one. One is the data and one is the clock. And the LEDs only look for data on the rising edge of that clock pulse. So trade-offs there, right? You need two lines of control instead of one, but you don't have the issues of trying to maintain a perfect 800 kilohertz signal rate for the length of one data frame for the WS2812s to receive any data. You can sort of take your sweet time. It's like whenever your what have you, your Arduino, your Raspberry Pi, your whatever is ready to output the next bit of data, it sets that bit on the data line and then pulses the clock line. And then it can go off and do other things. And that's what makes dot stars really attractive for controlling with real-time operating systems. You can't really control a Neopixel, right, the WS2812 style of these things with a Raspberry Pi directly, because you have to maintain this very specific frequency of data coming out of it over, not a long chunk of time, but a finite chunk of time. And in something like a real-time operating system, your operating system, because it's real time, is going to say, okay, I'm going to do a little bit of that data output, and then I have to refresh the screen, and then I have to see where Jeff moved his mouse, and I got to keep playing audio. The audio data's got to keep going out of that pipeline. And by the time it gets back to your task that's supposed to be outputting data, your frequency is no longer perfect and you're done. With a dot star, you can just, it can set up 2 bits of data, clock, oh, and now I go away, I do my other tasks, and the LEDs aren't confused, they're only looking for data when the clock line pulses. You can pulse them, I've seen some blogs online that say you can run them up to like 4 megahertz if your processor can keep up with it. So speed is not an issue, you just have to sort of take into account the need for this extra data line. So a super cool product. They're more expensive because they're not as common. They're sort of a slightly newer thing, and lots of different varieties there. Let's see. Adafruit says, strongly recommend to put a 1 microfarad capacitor between VCC and ground, says friends. Yeah, so that is a really good idea. A solid, stout power supply is really wise. Let's see, Thomas says, just because you can't see me working on my mini mover doesn't mean I'm not doing it. I entirely believe that. I want to see it, but that's no pressure. Dave asked a really good question. I think Thomas has got it there. Yeah, so the 470 ohm resistor on the data line that Adafruit recommends is just so you don't have too high of an input current or a voltage spike, a capacitive voltage spike on the first pixel in your chain, and you end up frying the chip. It's not as much an issue for controlling it directly with an Arduino, I have found, because those outputs aren't capable of, they're not super low impedance outputs anyway, but for a lot of drivers that can be an issue. We'll be putting a resistor in line tonight because it doesn't really hurt anything at the speeds we're talking about. At some point, if you were doing like dot star style things, up to several megahertz, I can imagine, at some point a resistor, in series with a capacitance to ground starts to look like a low-pass filter. And that could be a problem for signaling. But at 800 kilohertz, it doesn't really matter. Ooh, Thomas has tweets of spinning motors. Good. I want to check in with that later, Thomas. We're going to see some fun things. So how do you control these guys? So, we've looked in theory at what a Neopixel is. So these guys here have 7 Neopixels, 7 WS2812s on a little PCB. These are bypass capacitors studded around the outside here, 4 of them, just for additional ground and power decoupling. You can see it has that 470 ohm resistor baked right in. I don't know if you can see, it says 471 on this little tiny, probably a 0201 resistor there. And then it's got pads labeled in, power, ground, and out. And that's all for your power and your ground and your data outputs coming from there. So basically you pipe 7 LEDs worth of data into here, and it goes into the first pixel, which I don't know which one it is, but we'll see in a little bit when we plug it in. Let's say it's the center one. So this would see all 7 LEDs worth of data. It would lop off the first LED's worth, pass the next 6 down the chain, which pass the next 5, the next 4, and so on. So you basically get full control of these 7 LEDs with one data line. So what we're going to try and do, with all that preamble aside, is try and integrate that into a tiny moving light so that we have either, you know, an RGB light, or maybe it's a 7-emitter RGB light. And I'm curious to see how well this works. The basic theory of it should work. I have compiled code that has the ones I'd be concerned about are the servo library and the Neopixel library and the DMX library all conflicting with each other in terms of timer usage mostly, and they don't, and piecing through their code, there's another reason they should. The problem is going to be if the interrupt-driven-y stuff that we're doing to receive DMX and control servo starts to mess with the Neopixel timing, then we might have to get a little bit clever about when we're actually updating the LEDs. So there's that. In any case, let's start putting some things together. I'm going to grab a little bit of wire and just bodge it onto this Neopixel star here. Let's grab this guy. So let's see. So the standard Neopixel wiring length. Let me grab my DigiKey my DigiKey ruler that I have here. Let's see. Dave says running 160 WS2812s for driveway marker lights. Ooh, that's fun. That's super cool. Dave, is that a Christmas time thing, or is that just like a permanent install now? That sounds awesome. Might as well cut these to the approved per spec Demilight length for wire. Didn't like the resistor inline, but put a 5 millifarad cap across the PSU outputs. Oh, sure, yeah. Any additional capacitance to make your power supply stronger is not a bad idea. Permanent install, that's cool. Oh, that's awesome. Yeah, that's super. Do you have them doing like a runway, like land here chase? That's super cool. Chris says, does 094 have hookups for data? No, it does not. So that's going to be another challenge we have tonight, is how to get data out of this darn thing. Now, thankfully, we have some bodging places that would be the data lines that are running to the LED driver, which we won't be using. So we're basically going to bodge around that, which will be sort of exciting. We don't have them directly accessible on any of the through-hole pads. They're running from the processor directly to the AL8860. But I think there are a couple of vias and other places that we can solder to, hopefully. But first, let's see, how do we want to, you know what I'm going to do just for troubleshooting sake? So I have this, the nice flexible wire for when we install it in the thing. For testing purposes, I'm going to take out another star. I guess I could use this one, and do this first with solid core wire and a breadboard, and we'll just make sure that the code is working. And then when it does, we can solder up a second star real quick and use the flexible stuff. I think that's the sensible way to go. So we'll just use a little bit of our standard 20 gauge bell wire here. Oh, Dave says retrofitted underwater landscape lights. Ooh, that's clever. I was gonna ask Dave like how you're doing weatherproofing on any of that outdoor stuff. That makes a ton of sense. 7W2812s. Are those the ones with the a little half dome kind of thing? Runway lights for when I get home at like can't see at old. Yeah. I mean, listen, it sounds like you're solving that problem just fine. So I think you're fine. Let's see. Oh, Adafruit, they just make such good products. Look, the pads are labeled on the back as well, super clearly, as well as on the front. They're just so good. All right, so let's get those soldered up. I guess we'll have to pick another color of wire for our data input. Let's grab our solder. We'll grab our soldering iron, and we'll just touch these up. Maybe I actually, what I want to do, just because this is a prototype, I'm just going to run these the opposite way down through the star here, so I can solder from the back. And it won't be super pretty, but it's a prototype for purposes. We'll get that down in there. Yeah, so in terms of you could do in terms of triggering Dave's cool landing lights. Dave, I want pictures. That sounds awesome. Ways of doing like proximity sensing. Bluetooth is cool. Geofencing is super cool. I've seen some home automation systems, and Chris, actually, you might know more about this than I do, that trigger on. Jesus, why am I trying to do two of these at once? That trigger on like when a specific device connects to your home Wi-Fi, right? So if you always have your phone in your pocket, like most of us do, you know, when that device connects to Wi-Fi, it can assume that you're home. And when that device is not connected to Wi-Fi for, you know, X amount of time, it can assume that you're not home. I don't know if coming up the driveway is like the most Wi-Fi accessible spot in your home, but that's one proximity sense I've seen. Yeah, because it would want to be automatic, right? Like you turn the corner onto your block and your lights are shining and guiding the way home, as it were. A little more wire here. Let's see. Gonna have to mark this data wire with a big colorful something so I don't get it too confused. All right, let's do a little bit of white wire, and this will go into the data input, and nothing will go into the data output because we're not going to put another Neopixel something or other on the downhill side of this. Let's see. Chris says, has Chris's house lights turn on when I walk from garage to the house lights are on. Ooh, yes, very classy. Yeah, I like that a lot. In some ways, and this is maybe a personal thing, I feel like home automation, which I have not gotten super deep into, I will fully admit, I feel like it's, you know, stuff like that, functionality stuff, is sort of best when it's, you know, invisible, right? If Jarvis is just, you know, in the background somewhere, like, it doesn't make itself super known, it just turns your lights on when you need them, it starts the you know, even something like an automatic coffee maker, you know, it doesn't announce itself super loudly, it just quietly goes about its job, making your life better or cooler or funner, more fun, or whatever the term is. So yeah, I think this has got super cool possibilities. You know what else has super cool possibilities? This beer that I that I haven't touched yet because I've been so excited talking to you nerds about Neopixels. As always, no pressure to drink anything if you don't want to. I know it's not everybody's jam. It's my jam. This is a Fira from Half Acre. It's very full, as you can tell, because I've had none of it. I've had none of it. We'll see how it is. Oh, it's like drinking an IPA mango. Oh, I like that a lot. That's really tasty. Oh yeah, we're gonna have more of those for sure. Let's see. Is it time for more tummy cam? Probably. I'm only ripping the headphones off my head. I'm only having the brainwave now that doing this on a breadboard first would be a good idea. So of course I have none of those parts out. So you're gonna get to watch as I pull out all of my various bins of things. Let's do this. If I have a 5-volt Pro Mini, that would be my preference because that is the closest analog to the Demilight board. I think this one's 5 volts. I guess we'll find out. And here's a backup in case it's not. Let's see. Chris says, my cell phone goes silent when connected to work Wi-Fi, and the calendar says it's in tech. Ooh, that's a new level. Oh, I like that. Let's see, what else do I need? I have a USB cable. I have a programmer. This might actually be enough. I'll take the old wires off of there. Let's make sure that this plays nicely. This is our FTDI adapter. No, it doesn't play nicely. Maybe it plays nicely with this. There we go. So yeah, so there's my FTDI adapter. There's my Pro Mini, and let's come over to our Arduino IDE, and we'll just load the Blink sketch into it just to make sure it's doing something. Basics, Blink. Let's make sure we have a COM port. So that's gonna be COM port 8 today, apparently. Ooh, my face seems to be frozen. That's weird, but my screen is not? Is my face, am I looking pensively down to the right for everybody else? That's what it sort of seems like. but hopefully I still have audio so you can hear me. That would be terribly embarrassing. Let's see. So this is going to be set up for Pro Mini, port 8. Let's upload that. Camera is frozen? Yeah, weird. Well, while it's uploading there, maybe I can see what's going on. I think last time I just had to like enable and disable it. Just so you can, I mean, I know that the tiny face in the corner is what you all show up here for, so I would really hated to disappoint anybody. Let's see. Let us disable, deactivate, activate. Oh, deactivate, activate. This is not the kind of troubleshooting that I wanted to be doing tonight. All right, where are you? Stupid thing. All right, I'll unplug, plug it back in. If this doesn't, you know, get going in another few seconds here, I mean, not the tiny face is not really the point of the thing, but let's try. Ooh, I said USB device not recognized. That's not a great sign. I wonder if this is to do. Oh, hi. Now, of course, it's gonna be very blown out because it will have lost all of my things. Yeah, Francesco. So I'm not gonna power the Pro Mini directly, or the Neopixels directly off of the Pro Mini. I'm going to use, at this point, an external 5-volt power supply for testing purposes. Oops. And then I'm going to, what was I saying? I'm going to use, so the Demilight board has a built-in 5-volt regulator that normally would be used for like powering servos, but it has a bunch of additional headroom. So I'm going to run the Neopixels off of that, because that's also what's powering the Neopixels there. So I will do it. So that's exactly right? I can't pull the Neopixels directly off of it, but for the sake of this test, I think we'll be okay. All right, face is back. I know nobody cares. Oh, this face is now frozen? My God, what is happening? Let's see here. That's the important face. That's the hero shot, really. Let's deactivate. We'll activate. How bizarre. Huh. I don't know what's happening there. Francis, are you a teacher too? Not not officially. I am, or not in any formal capacity anymore. I spent my high school and college career and the early part of my professional career being a teaching artist. For various things, but at the moment, the bulk of my teaching is here. Wow, it's still frozen, huh? He frozen here too? Wow, that's like a really, I think this face, I mean, it's not the face I'm making anymore, but it kind of captures the disappointment that I'm having with this webcam. It's just like, that's a thing I'm gonna have to deal with now. Well, why don't we plug and unplug that guy? Because that one I would really like to have work, because that one's on a lot. This could also, so I upgraded to OBS 26.1 today as a streaming software, and this could be related to that. USB device not recognized, sure. Let's see, let's get rid of that and come back to it and see what happens. Still sad, huh? Let's see, what did I open recently that would be confusing things? I don't know. Sometimes OBS is really grumpy when other devices try to take control of its webcams. But that's not currently the case. Are we live over here? Hi. I move, I swear. I haven't been Medusa'd. Let's see here. So what could we do? I wonder if what I might do is just unplug the computer webcam here. So right now there's nothing that can be seen, but that's not really a particularly important view. It's really this face one here. Are you the only European watcher today? So, Francesca, we have Worston Boy comes in from Belgium every once in a while, but I mean, for you too, I imagine. I know it's very late there, so I imagine it's a slightly more onerous to stay up this late on a Sunday night to watch these things. Wow, it really just does not want to play nice. That's a bummer. I mean, listen, we have ways around this. We have the table cam. You can just watch. You can look at the table the whole night while I talk. But yeah, that's a bit of a shame, huh? I like my face. Well, I don't like that face. Well, I don't know what to do there. Hello. Oh, it's gone again. It's back. Oof. Yeah, that is bizarre. Well, very good. Well, here, while let me fix my color settings here, because I have opinions about lighting, and then we can carry on. I have no idea what caused that. I have no idea what fixed it. So that might happen again. For the moment, I have disabled the computer cam, so when we're over here, you're gonna be looking at me laughing at myself the entire time. Just because I feel like that could have been part of the issue, is that second camera acting up. But you know, everything else will still work. Maybe I'll just actually turn that off if I can, and then we'll carry on. Yeah, so we'll see how the spinning wheel down there, just so it's not looking at my weird ear the whole time. All right, back to the fun. All right, so where were we? We were looking at the Pro Mini. We were going to try some Neopixel stuff on it. So let's pull up a sketch here that we can play with. Let's just pull up an example. I believe I have the Neopixel library installed. I hope I do. Yes, Adafruit, Neopixel. So the couple of libraries that are sort of most popular for controlling Neopixels in an Arduino-like environment are Adafruit's Neopixel library and the Fast LED library. Let's see. So the Neopixel one is the one I've used in the library I was looking through earlier today. So let's see. Let's look at what this code is doing here. Which pin is connected to the Neopixel? So I want to put this on the same pin that controls the LED on the Demilight board, which in my case is pin 3. I'll need to save a new example. Let's call this Oh, it's making sad USB noises in the background of my computer. I don't like that. Demilight Neopixel. Call that. And the music is back. Oh, something is very cranky here. I don't know if you can still hear me. My meters are still going. I can't hear I can't hear anything anymore, but it seems to still be all right. If I go here, that's frozen too. Wow, this is unfortunate. Wow, this is bad, y'all. Do I have table? I have table. I just don't have any of the cameras that show anything else. So I could do this in computer. I could turn off all my faces, and I have the display here. The music seems to have like the background music is gone. Although maybe it's related to, I don't know, man. Wow, this is rough. Well, maybe we'll soldier on a little. Music is still there, so it's just not in my ears. I wonder if it has to do with like my audio interface disconnecting. Oh boy. It's fun to troubleshoot the electronics, but it's not as fun to troubleshoot these things. But for the sake of getting into this thing, I'll soldier on, and we can look at my face being startled there down in the background. That's kind of a common face, I feel like, when things are going wrong. So maybe that's just thematically appropriate. So let's see here. We've got the Neopixels will be controlled by pin 3. There'll be 7 of them. We'll create a new Neopixel object called Pixels. And here is where, so depending on the exact species of Neopixel you have, the color order that it takes data in may or may not be RGB. The true WS2812s are GRB, and that's what I think what it's defaulting to here. We'll see. I don't know what these little devices from Adafruit are, but I think they'll be that. 500. So let's see. So what is this code going to do? Pixels.begin, clear. For each pixel, set to a color from 0. So yeah, so then we'll just scroll through like a bright green picture on each, green color on each pixel. We'll wait 500 milliseconds, then we'll move on to the next one. And when we've looped through them all, we'll clear it and we'll start over. So that's a pretty basic demo. So let's get that wired up here. Dave says, great way to take out 2020. Whoa, I tell ya. Maybe it was hubris to update the stream software today, but I guess I don't. I do a test with my partner, my wife, every time before we stream, and it seems to be working okay. But maybe it's just 2020 karma striking again. Let's see here. So I have my power and ground leads on the Neopixel here. So I'm going to hook those up to power and ground. I should probably unplug this while I do it. We'll wire up ground so it shares a ground lead with the Pro Mini itself. Yes. And we'll do the data lead. I said was going to come from digital pin 3. So that's 1, 2, 3. So there we go. And then we'll need to power this up. So I'm going to pull in the leads from my power supply over here, which I will for sure remember to turn on every time, and for sure remember to make sure it's set to 5 volts. I've never screwed either of those things up. Not even once, and no one can tell you otherwise. Let's see. Jessica says, are SK6812s a WGRB sequence? You know, I don't know. I don't know about that. It's certainly possible. I mean, the nice thing is you can't really damage these devices by sending them the wrong color sequence. You just, you know, you end up with colors not being the colors that they should be. So it's worth a try. And if it doesn't work, then you change your configuration around and try again. Let's see here. So I'm going to plug in my power. I'm going to set to 5 volts. Good. It's all going great. Yeah, this is good. It's you know, it's fun. I know the music is still going out there. It's no longer going in my ears, and that's a little bit, like, I'm so used to having these smooth jams in my ears, and not having them is a little bit odd. But that's, you know, that seems like a survivable problem. Maybe we'll take another swing at solving that in a second here, but really just for my vanity, just because, like, I'm having moments of triumph, but the Jeff on the screen just looks so startled. All right, so now I've got my 5 volts on my ground wired up. Let's plug this in. I guess I should, this should be fine. So I'm going to put my power up here. Let's see, that's going to, oh, this is wired wrong. This should be going to the VCC pin, but I'm gonna send it through the raw pin on the Pro Mini. Ooh, there's something. They're defaulting to all on. We'll plug the programmer in, we'll come back to the computer, and we will upload. Oops, serial port does not exist. I swear the serial port exists, I just saw it. COM8, 18 mega Pro or Pro, oh. So you know what happened? By impulse, by like default, I hit the upload using programmer button, because that's what I use for the Demilight boards. And of course, it's not on a programmer, it's just plugged into an actual serial port for once. Let's see here. So that is not doing the controlling that it should be doing, which is unfortunate. It's a little bit warm. Let's see, I've got common ground, I've got 5 volts of power, I've got this coming out of pin 3. Let's double check let's turn things off and double check our wiring here. So we've got in to pin 3, power to the power rail, ground to ground. I don't think I need this extra, so I don't think I need that, to worry too much about the resistor, because there's a built-in resistor on, here, I'll show you, on this chip, and I've used them before in exactly this state. I don't think it's that. I mean, some decoupling wouldn't hurt, right? I also a little questionable, but like, I could whack a big cap on here just to keep the noise low near the chip. Let's see what we've got in our Boxo large caps. That will do the trick. A lot of these you can tell are salvaged from old circuit boards. So their leads are not necessarily the longest. What are you? 4.7 microfarads. That's fine. We'll just whack that in here. See what happens. Yeah, it's still all on. Let's see. I guess I could put a resistor in line, see what happens. Let's see here. I think I have... It's so funny, you can't see me, so I can like bend down and grab things with impunity. So luxurious. 10K, 1K, Do I have a 470? Yeah, 470 ohms. This is my package of 470 ohm resistors. So a very common LED driving value, so I just bought a bunch of them from DigiKey the last time I ordered. Nothing, huh? Why would that be? Why would that be? I thought we'd get a little bit farther than this before things started to break down. Let's just re-upload this code and see what happens. Uploading. Huh. Nothing. Let's take a look at this code here and see what we can find out. So, Neopixel library pin. Maybe I'm constrained in terms of which pin I can use. Now, I thought I could do this on any pin on port D or B, but maybe I'm wrong. Maybe I'm wrong. This is one of the advantages of using an actual Adafruit product is I can just check the website and see like, hey, am I wrong? Let's see. Let's go to products. We'll go to Neopixels and we'll just find this thing and we'll see if I'm mistaken about being able to put this on any. I was reading the library earlier and I specifically was like, oh, it can do anything on port B or port D, but it's certainly possible I'm wrong. Neopixel Uber Guide. Yes, that sounds good. How about basic connections? Digital pin. So this is telling me to use digital pin 6. Now, I did change it from pin 6. I don't know if that's a critical value. Why don't we assume it is and see what happens? We'll change our code back to pin 6 and re-upload. Still all on. Why? Let's see, I have my clock speed set up right. It's a Pro or Pro Mini. It's 5 volts at 16 megahertz on COM 8. Yeah, so that's the board we're actually using. I have my decoupling. I mean, I guess it's possible that I fried the first chip here, with doing this without the input resistor, except I'm pretty sure that there is a little tiny resistor on board, and I'm pretty sure that's its purpose. Let's see here. What is happening? Do I have my ground bonded properly? It looks like I do. 5 volts. And as long as we have a common ground reference, we don't need to have a common positive voltage reference. What am I missing? Did I screw the soldering up? Did I solder to the output? That would be a classic. Data input is green, is going to pin 6. Yes, that's accurate. Yeah, and it's going through a 470 ohm resistor on the board already. I can see the trace. Let's see. Is Pro Mini a 328 or a 16.8? It's a 328. It's a good question, though. That's weird. All on. Let's see. What are we missing here? 5 volt AC, yes. There's all these warnings, yes. What are we missing about? I feel like it's something in this library that I'm screwing up. Or it's 8 megahertz or 16 megahertz, so it's this. It should be 16 megahertz, but it's another fair question. Let's see. I don't know that I'll be able to verify except by reading the crystal. Let's see if we can get into that crystal there. Honestly, it might be easiest for me to read if I just zoom way in on it here with the camera. Let's see, let's get some more light in there. So there's that little tiny, that's our little crystal, a surface mount crystal there. You know, it might be. Let's program it as if it is an 8 megahertz crystal. It's a little hard for me to tell on the device there itself, and of course I don't think it's labeled. Yeah, so these were cheapium from China, and they're not labeled on the bottom what kind they are. So let's see, make sure I get this plugged in correctly. We'll plug the programmer back in. Let's try. The other thing I could do is pull up a known working bit of code that I've used Neopixels for before. Well, 5 volts. Yeah, no, if it's running at 5 volts, it is 16 megahertz on the Pro Minis at least, or it should be. Let me pull up some pumpkin code. So I ran some pumpkins that had Neopixel, these exact Neopixel boards inside them for Halloween last year. Let me see if I can find the code that I would have written for those, because that may tell us something. Yeah, huh. A rocky start. So Halloween, you say? So sometime October of last year or so. Maybe was it the year before? Before I had this computer, quite possibly. That's gonna make it harder, huh? Let's see. This would be dinner time for see you later, Thomas. Enjoy dinner. Let's see here. I want Neopixel test code that I have written that I know works on pixel speed effect. Oh, yes. Okay, so here's some. So this was a bit of code I wrote, which was also on pin 7. Isn't that interesting? On pin 6 here. So I was contracted to consult with a event installation company that had these like 7 giant plywood wheels painted like flowers, and they wanted the Neopixels that they had stretched around them to change color based on the speed at which children were spinning the wheels. Do we have a show command? Oh, we do. Okay. I mean, one thing I could do is just solder up another Neopixel board, assuming I either fried this one or it came dead. That's not maybe an awful idea, just before we go too deep down this rabbit hole. And if we're kind of, let's see. All right, well, let's give that a try. I'm so confused as to why this is not working. It makes me feel like it's maybe a hardware issue. Of course, maybe I'm feeling like that because the other alternative is that the issue is, as they say, between the desk and the chair, aka it's me. But let's give this just a quick try. Old Frozen Jeff down there in the corner, that's still an accurate face for what's happening here, it seems. So it's like, what is happening? Just bad 2020 vibes all around. All right, so let's try this again. Let's do power. Solder that in. It's so funny, I spent some time this afternoon like putting together most of a Demilight. I got up sort of exactly to the point of like, well, I don't want to get too far ahead because we can like build some things together and that'll be the fun part. And I didn't actually do this little tiny bit of testing that like, can I get a Neopixel running on a Pro Mini? Because if the answer is no, then we might have to punt to doing some fiery things tonight, which was my other idea for what we might do. That has more chance of flames. So I don't mean to be a tease about it. What that would have been when I hit upon this idea, which I think will be more practical in the long run and more interesting to see if we can achieve. Although if we can't, it will also have learned something. I harvested an old heatsink and fan setup from a 300 watt graphics card that I pulled out of the e-waste at work. And I thought it might be fun to see how much current we can push through an LED chip when it has, I know we've done like heatsink tests before, but to have a really high power heatsink situation. That was also going to be my excuse to like, I probably would have to switch to a different microphone. I have a boom mic, not a boom mic, a XLR microphone that I use for like doing voiceover-y things. It's big and chunky and ugly. But if you can't see me anyway, let's see, does the code differentiate SK6812 from WS2812? Yes, it does, and it is the Neopixel code should work for either, I should say, because the timing requirements are I think basically the same. I guess. Oh, I see what you're saying. Like if this is RGBW, am I just configuring it in a way that it doesn't understand? That's possible. Let's see here. Let's go into our library here, and if we need to, let's see. Oh, I can show you the library there. If we need to go and like actually look at the code of the library, we certainly can. Let's go to Arduino library use. Arduino library. All right, this is getting us nowhere. Let's go to GitHub. So we'll do new page. We'll go to GitHub, Adafruit, Neopixel, and we will just look at the library directly. That's not what I want. I want to be on the actual code on GitHub. And if we need to go find it, we can. Adafruit Neopixel. Okay, here we go. Let's just search for GRB, and we'll find where those configuration options are. RGBW is an option. Shall we try that? RGBW. All right, now we have this other star wired up. We'll go into pin 6. We've got, let me recolor my data line here. Ground, power, data, just so I can see what's what. Pro-Mini China clones. Oh yeah, you're not wrong. This is a cheapy product. It's possible that I'm being betrayed by this Arduino. I could also swap that out. You know what I could try and find? Speaking of code that actually works, so I stole the thumbnail for this stream from one of the earliest Demilight videos that I did that was like, oh, they're not color yet, but you could put a Neopixel on there. And I made a little demo board. Yeah, same thing. It's just all on. Why would that be? I guess I'll try uploading my speed effect code. I mean, it's going to freak out because it's supposed to have a potentiometer on one of these pins, but maybe it will do something. No. The answer is no. Well, that's a bummer. What the heck? Speaking of things to try, let's try an actual Arduino Uno that I know and trust and didn't come from a sketchy source. And while I'm doing that, I am going to just try power cycling this web. Hi, it's me again. Hello. I'm not going to bother reconfiguring the settings until this webcam lasts more than 2 minutes this time. But it's good to be back in the land of the living. Oh, it's going to try and like auto. Hang on, I'll configure again. A little behind the scenes of bad. Let's turn the gain down. Yeah, we'll turn the contrast up. And we turn the backlight compensation on. Ooh, no, we don't. Exposure is not automatic. That's the key one. It tries to like balance for things, but that's my job. I try and balance for things. Okay, hello, there's my face. We'll stick with that for now. And face works here. Hi, okay, great. So let me grab an actual Arduino. A real deal. Well, to be perfectly honest, it's probably not 100% real deal, but it's more real deal than where they like 80 cents that this other one cost me, I'm sure. Okay, so now to get these two wired together, we're going to need to connect the ground of our Arduino to the ground of our breadboard, and we'll need to connect the data to, let's say, pin 6. If this works, I will be delighted. If you try and detach the red cable, the color changes. Oh, that's exciting. Did it do that last time too? So when I move the data cable around, the color is certainly changing because it's getting little as I'm attaching and detaching, it must be getting little bits of data that like are the, you know, the right speed. So let's see, I need a new COM port here. Oops. Oh, I gotta plug the Arduino in. Plug the Arduino in. That's gonna be COM port 7. That's exciting. COM port 7. That is a Genuino Uno. And upload. We'll see what happens here. Compiling. Reading, writing. Oh, turn power supply on. Hey, there we go. That's not what it's supposed to be doing, but it is doing. So maybe it was the cheapy 80-cent Arduino Pro Mini that was to blame. That's interesting. That's gonna make, it's gonna make doing things on the Demilight board a little bit worrisome, because if this doesn't work, is it because it's emulating a Pro Mini, or is a real AT Mega chip going to be more reliable? Isn't that interesting? Well, I think the color issues that we have here are because I'm probably still in RGBW. Yeah, let's change our GRB, I think was the default for our color order. Let's see if changing that, yeah, we have our green. So that's good. So this is, so, you know, 20 minutes later, this is what it's supposed to be doing. Doing a little Neopixel chase there. Only green, yes, that green is deliberate. So in the code here, what it's doing is from 0 to number of pixels. So we clear everything out, and then for 0 to num pixels, we set the pixel color to green. So red 0, green. Oh, Chris wants red. Okay, we can do red. Chris, you know what we could do? Well, okay, Chris wants red. Let's get red. We could alternate. We could do like Christmas colors because it's still December 2020. We're allowed to do Christmas. There's red. Ta-da! We could do other fun things, but let's get this into a light, and then we can play with the fun things in it, because that's kind of the goal of this evening. Well, good. Well, I'm glad it was a hardware issue. I'm sad it was a hardware. So here's interesting. So these are clearly two different Pro Minis from different lineages. This is the one we were messing with that was not behaving. This is the one that was behaving. The Uno that was behaving. This is something different. I'm kind of curious, will this one play nicely, or are we going to be hosed when we go to that Pro Mini? Chris says, I'm not familiar with the code. Does it allow grouping? So not natively. So the gist of the Neopixel, there we go. The gist of the Neopixel control that you get, and the Neo Matrix library has a few more versatile things, but basically when you initialize your Adafruit Neopixel object up here, and in this case it's called the Pixels object, you give it the number of pixels you want to control, what pin they're attached to, their color, and then a couple of flags related to color order and speed. So here's that 800 kilohertz speed for the data rate that we were talking about earlier, and then these, I guess, apparently are GRB pixels, although the varieties, especially like the SK2812s, come in other places too. And then, so you call pixels.begin. It does a bunch of setup in the background, figures out what your clock speed of your processor is and sets some variables based on that. And then you only get a very few basic functions. Maybe we can actually go look at the API in a second here. Clear sets everything to 0. Set pixel color takes a pixel number and a color parameter to set them to. In RGB, right, 000 to 255, 255, 255. And then only when you call pixels.show does it actually send all that data out to the pixels themselves. So you end up being constrained in how many pixels you can control, your frame rate and how many pixels you can control and how complicated your effect is are all vying for, processor time and space. So if you wanted to control lots of pixels that were in the same color every time, you could just send show as fast as you could and get a very high frame rate. Although, of course, the more pixels you have, the more data you have to push out each time. Or you could do some complicated mathematical function, video wall, undulating effect, but of course, you would be eating up processing time doing those calculations, and you wouldn't be sort of sending that data out with this show function as awesome. Let's see. You could group... okay. So Dave says... I was told you could group them using a wrapper, but I don't know what that means. Could you speak to that? Yeah, for sure. So this actually might be a good transition into what I'm imagining we might do with this inside of a moving light at this point. And how we... So right now we're controlling each of these 7 pixels individually, right? As I do this, I'm gonna adjust my contrast again because I'm a little bit vain, I suppose, is the only reason. Oh yeah, something is strange here. Let me just let's turn this down to the levels that I like. There we go. Hello. In terms of grouping them using a wrapper, what that essentially means is you're creating some functionality of your own on top of the existing library functionality that's controlling each individual pixel. You're taking the existing functionality that does pixel by pixel and you're wrapping it up in some kind of additional function. So let's do an example using this board. So this is my... Good, I've already saved this as a new bit of code. This is no longer just our example code. I'm going to leave everything that Adafruit's written for us here. I'm going to hide the view of the table for now, just so you can actually see all of the code. And what I'm going to do here, so right now, if we were to put this into the light, to change the colors of all 7 LEDs at once, so just to make this an RGB wash light, as it were, not a terribly bright one, but right, for the sake of argument, we would basically need to do this for loop inside of our code every time we wanted to change the color. So if it gets a DMX message that's interpreting as, change this light to this RGB value of color, I would put a for loop in that code that looped through every pixel and set its color to what I wanted it to, and then probably after all of that, it would show that value on the pixel, right? So instead, it would be really nice to have the light be able to take an RGB value and sort of do all that for me. So we're going to write our own wrapper function that will do that. So we'll say something like void set light color, and that will take, let's say, 3 integers that are red, green, and blue. And when I call this function called set light color, I basically want it to do this. So I'm going to actually copy and paste some of this here. Well, maybe I won't. I'll say for int I equals 0, I is less than the number of pixels. So go through all of the pixels one by one. So I++, right? Increment that number by 1 each time through this loop. And I will say pixels dot... Now, I think there is maybe a functionality for setting blocks of pixels in the API now that I come to type this out. But we'll do this as a basic example. We'll say set pixel color I... let's see. Let's create a singular variable. We'll say my color equals pixels dot color. I think color is capitalized here. Yep. And that takes 3 values: red, green, and blue. And we'll just feed it the values that we gave it in our function definition here. And we'll set the value of all of those pixels to my color. And then, sort of as we decide, whenever we call this, we probably want those colors to show up immediately. So at the end of this function, I'll call pixels.show. So now, if I wanted these lights to, sort of all change color at the same time, instead of having this big for loop here, what I could say, I'll have to deal with where the delay goes at some point, is say, what did I call this? Set light color. Let's start with red, no green, no blue. We'll delay a delay value. We'll do set light color we'll do very red because Chris likes red. We'll do kind of green, a half green. We'll delay that same that same value we defined up top. And then we will set light color 0. We'll just do a dim blue, and we'll get a little bit of a sense of how these things dim. And then we will delay val again. And that should work. We'll get rid of this clear statement here. And so now when I upload that, in theory, if I haven't made too many typos, I have made some typos. My color, yes. So this object is of what is the name of the object that is I think color? Color my color? think that's right. If it's not, color was not declared. I don't know what the name of this this color object is because they're just doing it in line up here. So let's just do the same thing. We'll set we'll inline that code so I don't have to go and look up what the name of that the color type is. All right, let's try that. Oops, and I probably need a semicolon there. If you write enough Python, and these days I certainly am, you start to forget things like semicolons and other things that strongly typed languages like to see. All right, we're uploading that code finally. So now, there we go. So now we have bright red, not quite as bright green, although I think optically, I feel like we're, the green looks brighter, but I think that's just because the eye is pretty sensitive to green. Oh, hey, Cookie, nice to see you. No fire yet. That's the backup. The fire is the backup plan, I guess. We had some issues with things freezing. The Arduinos were messing up. The other webcam here is just a spinning circle. It's going great. 2020 is going out with a bang. Oh, Francesco, too speedy to understand. Francesco, what can I go back through? Maybe let me go back through this code one more time. So the goal of this was to sort of demonstrate the idea of a wrapper function, a function that uses the existing libraries to do something new, something simpler, something more in the wheelhouse of what we might want to do. So I'm not going to go, I guess, super deep into how a C++ function works. You might actually, Francesco, you might have some value in going back through my Introduction to Arduino series. In terms of writing original functions, episodes 1 and 2 are probably really useful there. But basically, for those who have seen some code here, so who have a little bit of code background, you can see this is looping over all of the pixels that we have, and for each one, it's setting them to the same exact color. And that's sort of cleaning up our original loop function here. Just because this would be a real pain if every time we wanted to change the color of all the lights, we had to put a whole, I equals 0, I is less than, that's just a lot of code that we don't need when our intention is just to set the light to one global color each time. So Dave, I guess this is sort of the idea of a wrapper function. It's a very simple wrapper, right? It's doing a very simple thing. You could, customize this in any variety of ways. Actually, here's an even simpler one. So one of the cool things about this, right, is it sort of feels like it has an outer ring and then an inner diode of colors. Maybe it would be nice to have a function that changes the color of those individually. So let's write those. They'll be very similar to our set light color function. So let's use that as a base. Rather than set light color, let's say set center color, right? So right now these two functions are identical, right? But rather than doing this for all of the pixels, maybe the set center color just does pixel 0. Just that center one, which is the first pixel in the line. And then to do the ring of outer ones, which is the remainder of the pixels on this wheel, let's call our function set outer color. And maybe this skips that very first one. So it starts at pixel number 1, right? Because things are indexed at 0, we're sort of starting beyond the first pixel. And again, we're setting them all to the same color here. So maybe, just to demonstrate that, we'll do set light color. We'll do let's see, how can we demonstrate this? We'll start with a dim white with all of the pixels on. Then we will set outer color. And we'll turn just the outer pixels to blue. So we'll do no red, no green, and a little bit of blue. Then we will set the center color to 150, 00, so that'll turn to red. And then we'll cycle through those three. So let's upload that and see how that looks. Blowing out the camera a little bit here, but you can see the lights start as white, then the center stays white while the outsides turn to blue, and then just the center goes red. So that's another kind of just wrapper function, again, using existing library functionality to do something that we might want to. Dave, does that sort of a track with what you're thinking of? The term wrapper just means something that sort of surrounds something else. This is sort of the idea that leaps to mind. Here we go. Dave says, so say you're running a number of your 7-unit pieces. Can you name groups of units? For sure. Let's Let's do that. So, let me unpower this for a second. And since I have a second Neopixel star here, which let's assume for the moment still works, let's wire that up as the next 7 pixels in line. And we'll see how we could control them both. So let's just make sure these connections are right. So this is power and ground. Those are plugged in. So there we go. And now this data I will need to solder into the data output of this first Neopixel, which is fine because we can always come back and undo this later for shoving into light purposes. Do a quick solder job here. You get a little forehead view there. Yeah, so I got the webcam working again just in time to show you my shiny forehead, so you're welcome. All right, so that's plugged in. So now, fire this up and fire the power supply up. Yes, good, I always remember the power supply. And this is actually quite good because this is not turning on at all, and if it was getting no data, I think it would turn all the way on. So now we can modify our code to address the fact that now this Arduino is controlling 17 Neopixels, or sorry, 17. This is controlling 14 Neopixels instead of 7. So let's look at some ways you might do that. We'll do this sort of one step at a time, right? So right now the board only knows that it has 7 pixels on it, right? So let's start by changing this number of pixels from 7 to 14 and upload. All right, so come back to the table, and hopefully, now we'll see, yeah, there we go. We're a little zoomed in here. Let's come back out a little bit. There we go. And maybe, how can we get these to show up a little better? It's like if I turn lights off so we can see the lights better, I feel like the camera is just going to adjust. That's not the worst. Maybe we can do our old trick of putting a piece of paper over it. Or a bit of frost or something. Well, this maybe will be good enough for our purposes for now. We can get fancy with it later. So you can sort of see still we're still running that same bit of code. We just changed the value, so from 7 Neopixels to 14. So it's when the data is going into the first pixel here, which is the center pixel on this star, right? It's sending out basically 14 LEDs worth of RGB data. This is chopping off the first one. And sending the next 13 bits of data onto the second one, which is chopping off the first one for its own usage and passing along the next 12 chunks of data to the next one, then 11, then 10, and so on, all the way down the line. So the last LED is just getting one chunk of data. It takes it, it passes along nothing. That's fine. There's nothing after it anyway. So right now, right, the functions that we have running, oops, I've unplugged it. There we go. Are treating we have a function that sends a color to all of the pixels, right? We're sending, I need something to diffuse this because it's really not visible, I think. Let's see if just oops, that's gross. Just a piece of paper, and we'll turn the big light off. And let's see if we can get these to, that gonna be, no, it's still pretty washed out there, huh? I think it's not bad. The white, I think, is not really reading, but red versus green versus blue, we can tell. Maybe I will try, what if we really reduce the exposure here? That's okay. I think it's a little bit strange. Let's see, what have I done? Yeah, all right. Well, let's try this, and we'll figure some more things. That's part of the fun of this, right? Is figuring out how to show this stuff on camera. Let's see if I do this. That's still okay. Right. So let's remember what our 3 functions are doing, right, in our code here. So our loop is calling set light color, set outer color, and set center color. In turn, with the color is sort of a dim white, a blue, and a red. Set light color is going through every pixel from 0 to the number of pixels that there are. So that's why all of the lights at the beginning part of that loop turn to the same sort of dim white color there, right there, and there, dim white all across the board. Then the center color, we call this the set outer color function. So the set outer color skips the first pixel. It says, I'm going to change my internal buffer of everything except the first pixel to a color I choose, so that everything after the first pixel, right, is going to change to blue. And that's why the next step is this first pixel stays white while all these 6 and these 7 turn to blue. We've said skip your first pixel, but everything else turns blue, right? And then finally, we change the color of that center pixel using the set center color function that we wrote. And that just says, okay, only change the color of pixel 0, the very first pixel in line, which in our case is just that center color. That very first pixel is this one right in the center here, so that turns red. Then we go back to the start of our loop. So we get all white, outer blue, inner red, right? But now, of course, right, we have the issue that, you know, when all of this turns red, or when all of this outer turns blue, all of this outer turns blue because, you know, it's just basically saying, it's not telling just the outer pixels here to change color. It's saying everything after the first one, which now includes these other ones. So we want to change that a little bit here. So, and how we might change it, you know, might be dependent on what we're trying to do with these things. But let's change each of these functions so that, Dave, this goes to your question. Let me say what I'm thinking we could do, and as I'm thinking about it, I'm not 100% sure it's achieving what you're looking to do. So let me say it, and if it's not, tell me I'm wrong and we'll figure it out, or call me. So I think we're going to give each of these functions an additional parameter called like light number, and it says, or I guess it could be light name, it could be light number. It says basically, you know, I want to set the whole color of this star, or just the outer color on this star, or the center color on this star. Or if given the, you know, if the light number is 2, it affects this star and not this star, or something like that. Does that achieve what you are looking for? Your reference to like referring to groups of units as like group 1, group 2 is not, I'm not quite translating that into code that way, I think. So help me out a little bit. Oh, cool. Yeah, so we can certainly do that. Chris says, is having individual control of each LED important for Demilight? I don't know. I mean, once we have it working, which hopefully tonight we will, we can decide. I don't know that like the Neopixel version will necessarily be like a primary goal. I just think it's a fun thing to do, and I think it'd be a fun thing for someone else to experiment with, and so I should definitely have connectors on the board for it to be possible. You know, none of the, you know, the Neopixels are not terribly bright, like certainly not compared to a 5-watt LED chip, say. We used to, as a rule of thumb, 60 milliwatts per LED per color is a rough estimate for power consumption purposes for the Neopixels. So you figure 7 LEDs times 180 milliwatts per LED, so it's like a watt of LED light, which is not nothing, but compared to the like luminance goals I have for the white lights, it's not super comparable. Let's see, 12 LEDs in one enclosure. Ooh, fun. Chris, I want to know more about this. Chris always has great Christmas projects. I want to hear more about that. Think of it as each group of LEDs acting as one big pixel. Okay, great. Yes, Dave, we can totally do that. So right now we have sort of like slightly individual control here and individual control here, but for coding purposes, what I'd really like is to say, this is pixel 1, this is pixel 2, I think is what you're asking. Or like, maybe this is pixel 0 and this is pixel 1, because we usually index from 0. Totally, we can do that. So that's a straightforward thing. Let us modify our, here, let's write a new function, so we're not modifying anything we've already written. So, right up here at the top, let's write a new function. Void means we're not returning anything, we're just gonna go out and do something, and we'll say, let's call this set, I like your terminology, set big pixel color, right? And that's gonna take some parameters. Like the others, let's say it needs to take the red, green, and blue value that we wanna set something to, and then we'll have to give it a number that represents which sort of large pixel in line is going to be affected. Now, what I think we'll do, since we happen to have seven pixels in each of these stars currently, is first we'll write the function that assumes that it's always 7 pixels, and then we can modify it in a way that makes that a variable as well. So we'll start with a simpler version. We'll say int num pixels per big pixel. That's a very long variable name, but I think it's pretty evocative, right? So we have 7 Neopixels that we want to treat as 1. So here's what we'll do. So let's first say, if we want to control, let's say, the 7 pixels in this star, that's going to be after this star in the chain, right? So the pixels here are pixel 0, pixel 1, 2, 3, 4, 5, 6. So this is really pixel 7, right? Will be the first one we want to address. And the last one we want to change is 7, 8, 9, 10, 11, 12, 13. So we really want to change, if we want to change the color of just this star, we want to change the pixels of, change the color of pixels 7 through 13. If we were to have another star here, and maybe we need to get one out, maybe we should get one out, it would have pixels 14 and 14, 15, 16, 17, 18, 19, 20, right? Those would be the 7 pixels in line that are there. So really what we want to first do is figure out which chunk of pixels we want to actually address. Assuming that our big pixels are indexed from 0, so the first one in the chain is number 0, we'll say int start pixel number equals num, right? The number of big pixel. Maybe this should be big pixel num. That's more evocative. So equals start pixel number equals big pixel num times 7, right? So if our first big pixel here, right, with index 0, the starting pixel is pixel 0. For big pixel 1, the starting pixel is 7. For a fictional big pixel 2, the starting pixel is 14, as we said, and so on, right? So now I can basically do a similar thing to what we did before. We're just going to loop over these 7 pixels in our big pixel. So I'll say for int I equals, and we want to start not at 0, right, but at start pixel num, right? I is less than start pixel num plus 7, right? We have 7 pixels to loop over, and I will increase by 1 each time. And for each of those pixels, I just wanted to set it to that color given by this red, green, blue function here. Now I could do this individually. In fact, I probably should. Yeah, so let's do pixels.set pixel color I pixels.color red, green, blue. Yeah. So now with this code, does this, I guess first thing, does this code sort of roughly make sense so far? How we're going to calculate the starting pixel of our big pixel, then we'll loop over that pixel and its next 6 friends, and each of them set them to a color. Yeah, you with me so far? I need a little a questions break, as we sometimes call it, which just means I need a sip. Excellent. Oh, Francesco, I hope to solve the Pro Mini issue. I want to press on with Neopixels tonight, but like it would not surprise me if it was partly due to the fact that I was using this janky Pro Mini. When we go to the actual Demilight board, which is basically a Pro Mini, we're gonna find out real quick if that's a limiting factor, or if it's just that like this one happens to be janky, or maybe dead. Like this one could have lots of. I had a bad habit in my younger days of killing electronics and throwing them back in the bin. Not worth it. So I do intend to solve that issue, and I think we're going to have to, so fear not. So now that we have this set big pixel color function, let's use it. So up here, so we can still, this set light color function is not really emblematic anymore. Let's call it set all color, right? Because this is going over all of our pixels and setting them to the same color, and that might be useful to us. So at the start of our loop here, let's do set all color. Maybe they're to like a really dim blue, just to give us a place to start. And then we'll set big pixel color, and that takes 4 parameters now, right? Red, green, blue, and the number of our big pixel. So let's set the first pixel in our line, pixel 0, to green. So we'll do 0, I don't know, 120, 0, and that's the first pixel in our line, pixel index 0. Then we'll set the second pixel, set big pixel color 0, let's say 100, 0, 0, 1, right? So this is a little bit of red, no green, no blue, and that should go out to big pixel 1. And then let's change the color of the second big pixel again, set big pixel color. Let's make that like a nice yellow. So like 100, 0, 100, 0, right? So that's some red, no green, some blue. I guess magenta, really. Some red, some green, some blue, and that goes to big pixel 0. And we'll just do another delay after that so we can see it. So let's upload that and see if it does the things we want it to do. Nope. No, it does not. Interesting. Why would that be, I wonder? What did I screw up? Let's see here. Let us start, let's just narrow it down. I'll bet it's in this newest function we've written. It seems unlikely that it's in that set all pixel, but we'll just comment out set all color in case that's what's breaking it. Although that seems to be the only thing that's worked. Yeah, so that seems to be fine. It's this new set big pixel color function that I've written that is not correct. Let's see, so start pixel num equals big pixel num times 7. Is that correct? You know what I really should do is this should not be a hard-coded 7. This should be a times num pixels per big pixel. We can just get rid of that. For int I equals 0, I is less than start pixel num plus 7, I plus plus set pixel color I pixels dot color red, green, blue. I would think that's right. Well, let's see. Red, green, blue, big pixel num. What it feels like to me is, what I think I'm going to do is it feels like to me I've created maybe an infinite loop somewhere. So what I'm going to do is just put something at the after these statements to see if it ever gets there, and I think it won't. So if we're proceeding through this loop and it's not doing anything, because we know the set all color function works, it'll turn red and then back to blue. If I'm getting stuck in an infinite loop somewhere, it will never change from blue. So let's see if that's true. No, ooh, it is red. Ah, okay. Well, that's good. So that just means, because that is changing, we are not getting stuck in a loop in this set big pixel color function. Pixels.color, that all looks right. Maybe I'm miscalculating start pixel number. So let's see, for big pixel number is 0. Start pixel number is 0. For int I equals 0, I is less than start pixel num plus 7, I plus plus. Set pixel I to pixels.color. There's nothing terribly complicated going on there. Why is this? What is happening here? What the heck? Red, green, blue. And it's not throwing any compilation errors either, so it's not like I've misspelled red or something. Huh. I plus plus pixels dot set color. There's nothing terribly complicated going on here. So here's how I'm going to troubleshoot this. I'm going to say that, let's just comment out these two lines. I'm going to say start pixel num int start pixel num equals 0. So this should just control the first big pixel all the time, right? That it's hard coded to only be the first star, if you will. And nothing. What is going on? Oh man, here's a classic error in working with Neopixels. I'm so sorry. Should have caught this earlier. You have to call pixels.show. You have to tell your Neopixels that you actually want them to output the data, and I'm not. Right? I have to call pixels.show so this data actually goes out to the light. Well, that's a silly error, but one that I have certainly made before. I'm so sorry. Well, that's an easy change. Got to put a semicolon in there, of course. We do like our semicolons. Uploading. Okay, and now we should see, now that I remember how to change color on things, right? So now we see at the beginning of our loop, we go to that blue color, then the first big pixel goes to green, then the second goes to red, then the first goes to purple, and then they both go to red, right? So to recap, now that I figured out what I was doing wrong, right? This new function takes a color and a, quote, big pixel number, and we're telling it that each big pixel has 7 pixels in it. So now, rather than doing sort of set pixel 1 to a color, set pixel 2 to a color, I have this set big pixel function that takes a color, right, in RGB, and a big pixel number, right, that tells which of the big chunks is changing color. Hey, Thomas, good to see you. Still no luck on this webcam, but this webcam is back. And we're doing Neopixels, so we're having a good old time. Dave, does that make some sense? Yeah, I think that's what you were looking for. The other thing we could do, like if I were doing a system that had, you know, only sets of 7 pixels in it, I would probably write it like this. The other thing one could do, I'm just going to copy and paste a new copy of this, is I could write a function, let's see, set lot of pixels could be my new function name, and it could take this parameter num pixels per big pixel as a parameter, right? I could say int num per big, right? And then in the body of my function, I could say big pixel num times num per big, right? So if I had a situation where you know, maybe this code also needs to run where there's 5 neopixels per star or 20 or what have you. This function would work. You'd say, you know, 100 red, 0 green, 0 blue, pixel 4, and there's 5 pixels per chunk, as it were. So that's how I would do that. Yeah. Oh, cool. Good. I'm so glad, Dave. Yeah, that's a really useful thing. And when we're writing, you know, functionality on top of these pre-made libraries like from Adafruit and stuff, that's a super useful thing to do, is like think about how, you know, in Adafruit's use case, they want you to be able to control each individual pixel. For our use case, doing that every time, maybe not necessary. All right, so we have this thing working. That's a very good sign. I think we should move on to trying to stuff this inside a tiny moving light. What do you say? I need to take a quote-unquote questions break first, so ask me if you got them. Otherwise, I hope you're all enjoying, if not a tasty alcoholic beverage, and again, I know that's not everybody's jam, maybe some hydration. Never hurt. That's very juicy. Oh, so good. All right. Let's see. Those color parameters are the ones which one day should be committed from DMX. Yeah, that's the idea. Pliers and hammers might be required for smashing. Yeah, for sure. Yeah, so Francesco, that's the idea, is that now we have sort of a basic proof of concept, getting the Neopixels running and struggling our way through that stupid Pro Mini issue. I'm mad about that. That sucks. Let's see if we can get these playing nicely on the Demilight board as it exists. So what I think I'm going to do is actually just move those off to the side, and now we're going to see about bodging these guys, one of these, onto some flexible wire and soldering it onto the board here. And while I do, I can turn the exposure back up here for a second. Having that be accessible is very handy. Thomas asked a good question, which I think I can. Sometimes I'm very successful, I feel like, in talking while soldering, and sometimes I'm really not. So let's see how this goes. Thomas says, how does one get 16-bit dimming info over DMX/ArtNet with those two addresses? I know there's a coarse and a fine, just not sure how to code it. A super good question. So, I guess a coding question could be easier to type it out, but yeah, let me put that question on pause, because I'm thinking and soldering at the same time, and it's not going well. But yes, I would love to get into that for sure. Let's see. So now I have this same like colorful. You know what? For the purposes of tonight, well, I was gonna say I was gonna do it with solid core wire, but it'd be really nice to shove it inside of our shell and have this like move and dance as a wash light, huh? We haven't even gotten to the issues that I think we're going to encounter tonight, so I'm stoked. All right, so this is going to be ground. I guess I should probably solder them in from the back this time, just so the leads are going in the right direction. We'll see how that goes, because I kind of have to get down in here, in and among these lights, but I think that's okay. I should say, so the WS2812s are pretty heat sensitive, unfortunately. I mean, you're typically not going to damage them just by like soldering some wires nearby, but there have been reports of people who have like damaged them, especially if you're trying to touch up the solder while they're on for troubleshooting purposes. That can really damage them. Chris says, do you worry about the LED getting interference from the servo data lines or the reverse? I'm not yet, but it's not a bad thing to think about. I mean, over a 9-inch run, no. But I will say, and I wish I had a better way. I have a video on my phone, but it's not going to be anything to look at over the webcam. When we were doing 6 at Shakes, we had the weirdest issue with the Neopixels, the WS2811 strips that were in that set. So that show, and I'll pull up a picture of that set in just a second here. The whole upstage part of the set was 9 towers of box steel. Dave, oh yeah, Dave, I'm still going with Sharpieing my my brown wire here. I'll get a PO box and you can send me stuff. So there was all this box steel and it was all covered in WS2811 strips, and we drove it with these controllers from Phoenix. Is that right? Falcon? They were called F16 V3 boards, and they're great controllers for driving lots of pixels off of DMX. The name of the company is escaping me for the moment, but they're awesome. They take ArtNet or SACN or DMX. They have lots of outputs. They do lots of universes at once. They're really amazing. And so the company in the UK that had been contracted to build this set built some little portable rack units that had some big beefy power supplies in them and multiple of these F16 boards and a bunch of really nice connectors. It was like, power on. There was some basic LED tape with power on PowerCon, and they used 4-pin XLR for 3 or 4-pin XLR for the data. It was really, really well done. But if the runs were more than about 5 meters, we started to get really weird interference, like static and flickering on all of the pixels, and the flickering was dependent on like the saturation of the color, which super sucked. And they ended up flying a technician out from the UK. Basically, they were like, hey, we think you've screwed up the install somehow, but we'll fly somebody out on our dime. If we were right, you pay us back. And he ended up spending like a day and a half troubleshooting and basically installing an additional controller to keep the cable run short. Woof. Falcon, thank you, Chris. Yes. Pixelcontroller.com. Yes, it was. They're great. They're super great boards. ACN on them. Oh, no, ArtNet on them, not ACN, but they're great. Francesco's going to... yeah, we'll keep fighting the good fight. Hey, Francesco, if you end up heading to bed, no worries. I get it. It gets late everywhere, but thank you for coming by. You could do a signal booster, and that could be as simple as like, a single pixel in line. There also are companies that... basically make a WS28. Even if you put a 2812 in line, it will regenerate the signal. Just you don't have to hook up any LEDs to it, so you can do that. I know there's Christmas light companies that do that. But yeah, a super, like you say, Thomas, super weird, super suck. I'll see if I can get the video out next time. It's like I say, it's just on my phone now, and I don't think that's going to show up particularly well. But now I got to think about how to wire this thing into the Demilight board. And this is why the 0.95 board needs special connectors for this. Because I need 5 volts and ground, and that's relatively easy because I have them on the servo pins here. And then it's where the data is. So maybe we do the easy stuff first and then the hard stuff. That seems to be the way. So let's see. So let's tap into the power and ground rails that are on the servo headers. And like I said, this is all just proof of concept, right? The part of the goal of this is to prove that it's possible, and then include. So I think the Demilight probably needs to ultimately include, some additional input-output capabilities, regardless, because I think this is a pretty neat use case for this board. But maybe you want to do something different with it, and I think that's awesome. And so having some additional, like having the other pins of what essentially is an Arduino broken out to various headers, or if not headers, then at least like SMD pads on the bottom here or something. Because right now, any kind of experimental stuff like this is really just kind of a pain. because there's nowhere to really tap into all that additional functionality that we could potentially have. This is a pretty bad solder joint here. Let's try this again. Let's get that flowing. All right, I think that'll be okay. Get the F amp from Pixel Controller. Yeah, Chris, I'd be curious what's in those. I feel like I'm pretty sure the F amp is, because doesn't it consume 1 pixel's worth of data, right? Or do you need a D amplifier at the other end? Because otherwise, I think it's just a low impedance, like a WS2812 with a FET on the output line. I might be wrong. All right, so now, and that's not a bad thing. Like that would be the way I would build it, which maybe does mean it's a bad thing because we're seeing how this is going. Now, I need to wire in the signal line to one of the pins on this Arduino here. Ooh, you know what we should do before we do this is verify whether that pin 3, pin 6 thing was a function of that Pro Mini debacle. The FM doesn't consume. Oh, that's cool. Check that out. I want to see if these Neopixels will run successfully on some other pin. Like I say, from my investigation, they should, but let's see if that's really true. So let's come back to our Uno code here, and here, let me open. I'm sorry, my phone is ringing. Hello. It's yes, wife. It's going quite well. They're good. We had a little bit of flaky hardware that was throwing us off for a while, but we're making solder smoke here, and it's all going pretty well. I will let you know. Nate says hi, and so does Chris, and they want to know if I need to extend my car's warranty. Fair enough. Thank you. Love you too. Bye. I have the best wife. She's great. Oh my god, that's very good. Doesn't that phone sound great? I hope you could hear it on the lav. Like that ringer, just that ringer sound is awesome. Oh man, that's tremendous. So good. So good. All right, let's move some wires around. She gets me. She's very good. So we've moved our wire to pin 3. Let's move our code to pin 3 and let's re-upload and just see. Oh, I guess I'll have to turn our power supply back on. Let's see if it works exactly as it did before, and it does. Okay, so that whole like pin 3, pin 6 thing, that was a remnant from the like trying to get the Pro Mini working, and is not a core part of the functionality, which is good because we don't have pin 6 available on the Demilight board, I don't think. Which, speaking of, let's open up our Demilight code here, sort of de facto one. Yes, so the LED control is on pin 3. So that's the pin that I'm gonna want to reuse for controlling the Neopixels. So now I have to figure out which pin that is, and I think the easiest way to do that is just gonna be to pull up the circuit board design. Chuckle when the phone rang. Yeah, it's pretty. I mean, it's one of the, like it's both odd and really refreshing to like have a phone ring and pick it up not knowing who's calling and have it like probably be someone you actually want to talk to, right? Like I feel like most of these days, like, oh, this is, in fact, the first time I called my wife from my office number, she let it go to voicemail because who answers a phone number they don't know? But now I'm just like, I'll pick up. Haven't gotten any spam yet. It's been online for 48 hours. We'll see. We'll see how that goes. So let's see. So let's open up our Demilight 9.4 board and figure out which of these, where I can tap into this signal line that's going to the LED dimmer. So that is, so here zoomed way in, this is our microcontroller here. Here's what is the equivalent of Arduino pin D3. It's pin 1 on the microcontroller. So let me zoom in here. So that is this pin just here right by, so I could probably solder directly to that, but let's see if there's a better option. Frozen Jeff makes me laugh. Yeah, 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 I don't know what's going on with that guy. He's really, I mean, he's really having kind of a confused... Has Frozen Jeff changed in that corner? I feel like he didn't used to look like that. So pin D3 here, the trace goes up, goes through a little via, goes to this via, goes to pin 8 of the other form factor of the AL8860, and then goes to this pin of what I think is a... Oh, is that a resistor? What is this component here? Yeah, it's a pull-down resistor. So maybe I could tap to that. Let's see where that is. Thomas says we're gonna tap to the... yeah. I need the servo pins to still have their own functionality, right? I definitely have tapped to those when I've been experimenting with the RDM stuff, because they're the only two other digital pins that are really easy to access. I have an LED on pin 11, but I like to maintain that for other indication. So I could solder to the... I think I'm gonna do this. I'm gonna solder to that edge of this little LED, of this resistor here, which is connected to that same net. And that'll be my control point there. So let's get my flux out there, and I'm gonna get my smaller roll of solder out. I have a roll of, what is this, point? This is 15 mil. The stuff I have been using, I think, is 31 mil. We'll just go for the super small stuff, just to try and make this a little bit more controlled. So we'll trim the ends there. And already fluxed up. Might be easier if I can't do it this first shot, I might pull out the PCB vise, but... Ooh, I think... let me just reposition a little light so I can see what I'm doing. I guess I should probably put my safety glasses on, huh? That would be the good thing to do. But we'll just come right in here. Try not to melt the servo wires behind me there. Gonna need a little bit more solder on that joint here. We'll come right in there. I mean, now I'm also doing this with a big fat chisel tip point, which is not ideal, but I think... Let me this is like a little hanging chad of wire here. Let me neaten this up a little bit. There we go. Tin the wire a little bit. And... go. Reflux things just for good luck. Hate that Chad. Chad's the worst. Chad, this is unrelated. Chad is the name of the character my wife is currently playing in our D&D group. He's a human bard. He's a delight. Okay, I think that is attached appropriately. If I end up having errors, maybe I will go in and continuity test that. But I think I'm feeling lucky. So I'll zoom you back out here. Let me get the programmer in place. So I'm going to move the Arduino Uno out of the way. We'll bring the tiny ISP in. Plug that in. And we'll plug its programming header in, which we should have 5 volts there. So I guess what I should do, actually, is before I get this running, so the 5-volt rail that feeds the processor and things is the same 5-volt rail that's, coming from the ISP programmer, so it's all one 5-volt bus. So for testing purposes, I often just power these circuits off of the ISP header. But I'd really like, when I fire these Neopixels up, to not be pulling, like, half an amp out of this thing, so I should probably hook up my input voltage here on the Phoenix connectors and let the voltage regulator do the hard work. That would be more wise. Let me pull a little screwdriver here. We'll get that fired up. Oops. All right, there's our positive voltage. There's our ground, or our negative voltage. The guy that who got a Demilight for Christmas is a big ol' lighting nerd, as you can imagine. He works for a company that is like the Illinois distributor for ETC. And so when I was prepping the light for him, I got like super nervous because like it doesn't obey exactly the DMX spec. Like it takes standard DMX, but it doesn't obey like all of the floating ground strategies and like all the unit loading specifications. And I was like, is he gonna? No, he had a great time, but I was like a little bit paranoid that I was giving him this substandard product. So you can see now I've turned my power supply back on. Now I'm getting 5 volts just out of my voltage regulator, and that's what's going to mostly power this Neopixel. I don't know if Francisco, if is still with us tonight, but to his point much earlier about like don't want to power a bunch of Neopixels directly off of the central power supply of like the Arduino Pro Mini power supply, which is basically what's inside here. Now I'm going to use this 1 amp voltage regulator to take care of all that. So now we'll plug in our programming header. Oh yeah, Chris, what happened with Apollo? Was there a fire? What happened with Apollo? All right, so what I'm going to do first is just run, let's come back to the code here. Let's just run, I guess literally exactly the same code we were running. So of course we don't have a second sort of big pixel attached, but we'll still see some things happening. So this is just be a proof of concept to see if this works. So we'll upload, we're uploading. Suspected arson, oh my goodness. That's crazy. Woof. Yeah, that looked bad. Woof. Oh, what an awful, I feel for those people. Like, what an awful way to end a year. What an awful thing anytime, but holy crap. All right, so this is a good sign. So I have our Neopixel star working here, right? It's you know, doing, it's behaving like the first big pixel in our chain from our previous code, right? Because that's essentially what it is. Yeah, Dave, it's really, I feel like I saw a picture flash by, like, it was like over Christmas, and, oh man, yeah, really, really rough stuff. So this is a good sign. Yeah. So what I'm realizing, and I'm going to decide how much I care, is in the assembly guide for a Demilight, which is currently just a Google Doc, you're supposed to feed the wires through the body before you solder them in place. And I'm deciding how much I care for the sake of tonight's experimentation. I think I do care. I think I want this to look good. So we're gonna desolder these and resolder them. It didn't take that long, and I think I'd like this to be a thing I can keep around as a demo. So we'll just pop these solder joints off. We'll feed them through the body. I'll make a solder bridge. I'll take it away. All the usual goodness. The theater community will come help them out. Yeah, that super duper sucks. Arson, that's super scary. When I moved into my workshop at work last year, hanging on the wall were a couple of the old like 18-inch Apollo effects wheels for their effects engine, and I was like, yeah, I'm home. This is good. Oh, yeah, I feel for those folks. All right, what I'm not gonna do on this version is the cable wrapping, like the semi-flexible sheath. Am I? No, I'm not, because I'm gonna want to like cut it to length and heat shrink it. These wires are just gonna hang out all everywhere. This is a proof of concept. This is not a finished light. That's fine. When you build yours with the plans that will be out by January 10th, I'm going to say it again because I feel like I just have to commit. You can do it with whatever pretty way you want. I'm not going to worry about it for tonight. Okay, so now here, you know what? I'll bring up the assembly guide and we can double check this. Assembly guide being this Google Doc that exists in my docs. Let's see. So I got up to center both servos, solder LED wires to PCB, and then install the PCB in the base. Great, so that's what I want to do. So now I can just redo those solder joints that I just fix here. January 10th is too soon. Chris, did you get a printer? Did you get a printer for home? I know Chris has access to some cool printers through work. Did you order one for your very own? I'm excited for you either way, but all right, so ground goes to ground. Get the flux back out. I'll just tap this in here. All right, so So that's ground. Boop. Ooh, excited to build it. Did you get... Ooh, okay, so now we get to guess what kind of 3D printer Chris got. I'm assuming it's a 3D... I guess you didn't say 3D printer. I'm just going to guess that you wouldn't get this excited about building your own inkjet. But, you know, hey, like, whatever your hobby is. Ooh, Nate ordered a Mark 3S Plus kit. Yeah, that's Chris, that's what I was going to guess you got as well. Am I on the money there? Yeah, those Prusas are just... I think I know I've said before, like, for the price, they are easily the best. They're the best prosumer printer. The value you get for money is just incredible. Same for, yeah, awesome. That's fantastic. Yeah, the Mini has, because I'm doing such, you know, relatively small things, and I have a second one to back up to, I'm sticking with the Prusa Mini for now, but I'm super excited to see the i3 Mark IIIs come together, because that is a super, super cool product. And the versatility you have with future accessories, right? Like the multi-material adapter, like, you know, the Mini is going to be basically just the Mini forever. The amount of customization accessories on the i3, I think, is really exciting. So when the Demilight goes into production, maybe I'll treat myself to an i3. Okay, so that's threaded through and now reattached. So let's just turn this back on and make sure the star still works before we get too much further. Power, yes. Okay, that's good. Dave said, "Did you order one for me too?" Ooh, oh, did anyone remember to order a printer for Dave? Do we order a printer for Dave? Did anyone order a printer for Dave? I hit my headphones with the phone. Stupid joke. Don't use the 2 with the maker. What is the maker box, Chris? Is that the, like, manual filament exchanger thing? All right, so now, next step in assembly here, install the PCB in base using screw. I'm really thankful to Past Me for writing this guide, because you'll remember when I was trying to assemble them without the guide, and it was a mess. All right, so one of the things that I've done to try and reduce, like, parts headache on these Demilights is, so the servo in the cover, right, attaches with 2 of the servo screws. The one in the lid only takes 1 servo screw, and so the additional one that you get with your second servo is the screw that you use to install the PCB into the base. Right, so that's going to be our... And as I'm looking at it, I probably should increase those clearances just a little bit for the next version, but I'll probably just trim this down for now. This is also the kind of thing, like, this like big flat washery part on these screws is not something that was in my very first batch of servos, and now I'm into my second big batch of servos, and it's wider, so I should probably just be really generous with the clearance, huh? I'll make that change before I release the plans. I'll just be extra generous with it so people don't get accidental shorts and fires and things, unless you want shorts and fires, but I'm getting the vibe that you like them when I have them, but not necessarily for yourself, huh? Oh, the MakerBot Replicator 2. Yes, Yeah, the only like the reason that I would want multi-material capability is for soluble supports, because I really and this is a deficiency in my making strategy, but I really strongly try to avoid printing with supports at all, which is not necessary, right? Like they are a part of... Oh man, I soldered these wires all the wrong way. I mean, they're the right place, but like this wire should be heading that way, and this wire is pointing... Yeah, I'm gonna retouch these so that they're heading in the right physical direction to get out of the enclosure. Just tap that there, and has material. Yeah, I'm really curious. Like I feel like that would... I'm imagining it would reduce the pain of printing with supports, but I guess I don't know. Yeah, so I'm curious about it. I had a friend reach out at, just before the holidays about her partner is a huge fan of some music act to a very distinctive like speaker setup, and so she had designed in AutoCAD a replica of that setup and was going to get it commercially 3D printed. So she found some vendors on Etsy who were doing like really high resolution 3D printing, which is super cool. And she reached out to me for advice about like, hey, you know, they're proposing these like 3 different technologies. Do you have any feedback? And one of the technologies was, and I think it, I don't remember if it was FDM, like the standard plastic FDM printing, or SLS sintering. It must have been FDM, but it was, SLA, like in a resin vat. That doesn't make sense either. In any case, the whole point is the support material they were using was wax. And you basically, it was like solubles, except that you printed with your supports as wax, and then they melted the wax away afterward, which I had never heard of, but that sounds super cool. I mean, with SLS, you have like the remaining non-sintered powder is your support, I suppose. But they were like, no, it's just wax, and then you do like a lost wax casting, essentially, except it's a 3D print, which is wild. Thomas says, well, I'll read what Thomas says when I screw this screw in correctly. Hang on. Soluble supports are more of a pain than normal ones. Convert my printer to a 2-in-1 dual extrusion machine. Any one nozzle system that mixes filaments, I see. Yeah, so if you had like, doesn't even like Wanhao now has like a dual extruder system where you like do one material in you basically have 2 entirely different extruder systems and nozzles and everything else. And maybe that would be more successful. All right, so that's the PCB installed. What's our next step? Plug pin and tilt servers into PCB using headers. All right, I can do that. So this is my tilt servo. So that goes into the PCB slot labeled tilt. That seems to make some sense. And the pan servo, which is on the cover here, goes into the pan header there. But plugged in correctly would be good. Yes, okay. Now, insert pan servo cover using sticky bits, ? Yeah, so one of those unsolved problems that I'm trying to let go and just be okay with as I release these is, the thing I've been bringing up for ages, like how does this cover for this pan servo actually stay on? Because right now it's just pressure fit, and I've decided that my solution currently is sticky bits, aka in my case VHB tape. It is purely aesthetic. It doesn't actually do anything, so there's no reason it has to be there. But yes, a thing that it's important. It would be a good thing and probably a fun thing to try and solve, but just like a time-consuming rework of the 3D models. So I'm just saying, if you want it, glue it down for now. Ooh, yeah, Parisa love to ship gummies with their products. That'll be super fun. All right, insert lid into base case is my next step. So now this slides in here, and all these wires got to come out through this hole, except the pan servo wire, which just doesn't have to go out and back in. So we'll go down that way, and we'll use a little screwdriver to just help this lid up and into place. All right, now insert yoke onto pan servo using screw. Some filing required. Ooh, it looks like I didn't finish the guide there, but that's okay. There's only 2 steps left. So I have this pan servo. Yeah, so this is the some filing required step. So one of the things, going all the way back to like what I'm trying to get done to get these files releasable, is think about tolerancing. And actually the talk of all these new fancy 3D printers is pretty germane. Did I center? I did center these servos ages ago, yes. That was an earlier step. I have till January 10th to finish the guide, yeah, for sure. Or at least finish the last 2 steps. One thing that is definitely true is that even having printed half of these parts on my little Maker Select and half on the Prusa Mini at work, the tolerancing is really different. Just because they're different printers, they have different amounts of slop. And like for example, I can tell this piece was printed on my Maker Select, not only because it has a brim, and I don't need a brim on the Prusa Mini, but this nubbin, there's a little nubbin here that is part of the overhang. As the part prints like this, it's only present on the parts that come from my Maker Select. It's like whenever I'm filing out this specific hole on the Mini Moving Light, I'm like, oh, Maker Select part. So what do I do about that, given that the goal is to like put these parts out there for people to print on their whatevers, their printer bot originals, their i3s, their maker bots, you know, whatever you have. And my answer, I think, and I'd be interested how those who have, especially those who have 3D printers coming, feel about this. I think the right answer is to make all the tolerances a little bit too tight, and just say like, hey, this is deliberately too tight. You're gonna have to file this out, especially with these servo attachment points, because the friction of the part with the servo post is such a part of the mechanical interface between those parts. I did experiment. Oh, I should say, I don't know if it was Dave or maybe Palmer at some point when I was having this issue during some assembly was like, why don't you just use a lock washer? And I remember I couldn't get my head around, like, I think I kept insisting that a lock washer couldn't go anywhere. I was just wrong. For this light that I sold to this friend for Christmas, I experimented with a lock washer, and it worked okay. I ended up buying all a slew of all of the tiny washers that our local Menards hardware store had, from 1.6 millimeters up to 4 millimeters. A 2 millimeter washer, of course, they didn't have any split washers in that size, but a 2 millimeter washer fits just about perfectly in that form factor. Means do the Neopixels need a heatsink? I don't think so, but let's find out. They're only going to put out about a watt of power max, maybe a little bit over, so I think we'll be okay, but I guess we'll find out. They are in an aluminum PCB, which will help some, although I just watched a really interesting video today that was doing some experiments between copper and aluminum PCBs, and the conclusion that he drew, and this was from SDG Electronics, which is a cool channel. If you haven't seen him before, he makes circuit boards and things. His measurements of running, 2 identical circuit boards with identical LEDs on them, one of aluminum and one, not aluminum versus copper, aluminum versus FR4, that plexiglass substrate that's on PCBs, was that if your copper layers have proper thermal vias, right? So underneath your LED, you put some vias between your top copper layer and any of your other copper layers to help suck away that heat really fast. The difference between FR4 and aluminum was marginal. Like was in his setup less than 1 degree Celsius, which was cool. Now on a board like this that doesn't have a lot of thermal viaing and maybe can't just because of size reasons, maybe aluminum is significant. And he did notice like the aluminum has more thermal mass than FR4, so if you have really brief, really intense heat loads, maybe the aluminum has an advantage. But I had always thought that like the aluminum stars that are on all these LED PCBs were a necessity, and it seems like they are maybe not as critical a material as it seemed. Sadly, no fire today, says Chris. Yeah, I mean, we've thought that before. Are you saying that fire would be more exciting than watching me file a little tiny hole into a slightly larger little tiny hole? The other thing I have done, and I haven't done it in the plans yet because I think it's going to be situational, you can see when I press this first hole in, it cracked between the layer lines of this print. Here, I'll show you there. And I've actually experimented with just cutting that hole into the part and letting that be a little bit of slop. But it varies so much based on exactly how much filing you've done and what the tolerances are on the specific prints that I think I'm going to not make that a part of the printed files as designed, but just a thing you can, take a razor blade and go in there and, slit between the layer lines, and give yourself that little extra bit of clearance. And if it cracks on install, then you know it's as tight as it can possibly be, and that's not necessarily a bad thing. All right, so let's get this attached here if we can. Let's see, this wants to be vertical. Ooh, yeah. Nope, not quite yet. Got to do more filing. Let's get that screw out of there first. Do a little more filing. I got spoiled by having access to the Prusa Mini at work. I think I mentioned last week I will not be in the building for work for all of January. Hence doing some fun things to like spiffy up the workshop in the meantime here at home. But I will miss having access to that mini. Nate says, did you end up printing your lav mic holder from last week? You know I didn't. You know I haven't yet. I got wrapped up in printing little tiny light parts, and I didn't even think about it. I probably should, huh? see how theory turned into practice on that one. Especially because my lav has therefore been sitting, like I say, just on my desk or on the floor all week, which was the whole point of that. Let's see. So yeah, so this is being particularly stubborn, so I'm gonna do the thing where I make a commotion, where I just take a single edge razor blade, which are a great tool. You can get a box of 100 of these things for like $4, and they are a great tool for making little cuts or cutting foam board or poster board. I'm just gonna notch this out a little bit. I might need to get an actual X-Acto knife or something. Which of course, the X-Acto knife used to live in that box, but then I rearranged the shop today, and now where does it live? Oh, you know what it is? I misplaced it after opening presents with it. But that's all right. I can use... I'll just get a sharper blade. Finger check. I still have all 10 so far, Chris, which is a good sign. Dave says, ooh, old dental picks. Ooh, I like that. That's pretty cool. That'd be a great tool to have. All right, let's try this one more time. I might be able to. I mean, on the one hand, it's nice that my layer adhesion on this print is so good. There we go. Okay, so now it's got a little cut down in there. That should make it a little bit easier to get on here, although it'll make the friction a little bit worse. Oh, to go back to my lock washer story from this light that I built for the friend. So I experimented with the lock washer, but I ended up actually putting a drop of super glue in a CA glue in each of these joints. And that worked best of all. Now I did that super glue on top of the lock washers. Here's more filing. But so I think the additional surface area and interface surface of the lock washer did help some. But ultimately I decided, like, you know, I don't like to glue them because I probably want to take them apart and mess with them some more. But for something I'm giving to somebody else, it just seemed wise to have it be as rock solid as possible. You know, I probably should have given this another test before I put it all together. Yeah, so you can see the problem with it splitting is, like, now the friction of this is causing that to split additionally, which is not great. But that's the gist of it there. We can leave that side cover off for now until we get this tested. But let's get it tested. So currently, right there, there's no DMX software on this yet. When I power this up, it's just going to go through its little Neopixel cycle again. But let's just make sure it still does that after my chicanery. Yeah, that's a good sign. Wow, that's already exciting. Yeah, that feels pretty good. Okay, so now we got to integrate this code. No ballyhoo yet, Chris, right? Because this is running exactly the same code it was before. It's just literally this Neopixel is sitting inside of a plastic shell. Let's merge those two codes so that we have a DMX controlled Neopixel light. That'll be the thing to do. So let us open our control code here. We'll save this as the Neopixel version of the code. And I'm going to borrow pretty heavily from the code we wrote earlier. So we'll include the Neopixel library. And actually, before we get further, let me just make sure this compiles, which it should. There shouldn't be any conflicts, but if it didn't, we'd have a problem. Okay, so we're fine. Chris, is there only some of the red working, or is that the camera? And blue? I think it's just the camera. Let me see here. Oh yeah, you're getting strange glare here. We'll go back to low exposure mode so we can see everything. Yeah, so the RL where either, I think what was happening is the work light that's just above here was reflecting back to the camera, making it look strange. But no, we got all 7, so that's good. Yeah, Dave, I'm delighted we figured out that mode. All right, so our code compiles. That's good. Oh, you're back to spinning blue circle view. That's fine. So here we go. So LED pin is still pin 3. Set start address. We'll put this at address 1. That's fine. But instead of doing any of this analog writing business, I'm going to want to do my Neopixel setup, which I'm just going to steal from the Neopixel code here. Yes, define pin is 3. Neopixels, we're going to have only 7. And we'll define our Neopixel object here in setup as well. That seems good. And again, let's just make sure that this compiles. Sometimes you get, if with sloppier libraries, you get like weird conflicts where things are double defined. Now, I don't expect the Adafruit libraries to be that, but here we are. We'll want to do pixels.begin. Let's compile that. Yeah, should be okay. And then, so I guess one of the things that we'll run into here is that on the original Demilight code, the DMX map is intensity on channel 1, pan on channel 2, tilt on channel 3. So we have a couple of choices here about how we could choose to write the DMX map for the Neopixel version. Let's pull up the Neopixel library documentation, because I think there is a method that like fakes the setting of the global brightness, which there's no like, let's see, get brightness. Is there a set brightness? Yeah, not intended as an animation in and of itself. Changing brightness isn't a lossy operation, so that's not what we want. So maybe what I was thinking is we could have channel 1 be global intensity, channel 2 be pan, channel 3 be tilt, 4, 5, and 6 could be RGB, if that's interesting. Chris says, is there a standard for moving lights? Wow, what a good question. I don't know. Let's go to something like, let's go like the Mac Encore. Mac Encore Wash Cold, which is we defaulted to the Encore as like our go-to theatrical moving head color light while I was still working in theater. Let's see here. Downloads. Let's download the appliances, firmware, safety, and user guide. That's what I want. I want the DMX map in the user guide. DMX protocol, page 21. Let's go to page 21. DMX protocol. Shutter strobe, dimmer fade, cyan, magenta, yellow, color wheel, iris, zoom, function, pan and tilt at the end. That doesn't feel typical to me. I feel like you normally see pan and tilt at the beginning. Yeah, I don't. I mean, just as a point of comparison, let's go to like the ETC Releve. Ooh, yes, Thomas is back at 16-bit dimming question. Now, it won't be 100% relevant here, Thomas, of course, because we have only 8-bit dimming per color in this case, but this would be a great chance to talk about 16-bit dimming and how you'd program that out. That's a thank you for bringing it back. Let's see. Let's just take a look. Not that the Releve is like a standard moving light, but it's, you know, it's gonna be spec'd in all of the theatrical installs, all the like the high school installs for the rest of time. So you might as well look at it. Manual channel map reference guide. Here we go. Intensity RGB strobe, pan tilt. So yeah, good color at the beginning. I mean, this is all arbitrary. But let's, you know what? Let's do this. We'll do. I'm gonna make the executive decision tonight that it's intensity, pan, tilt, red, green, blue in 6-channel mode. We could also develop different personalities for it, right? We could say like, here's a red, green, blue mode. Here's an HSI mode. Here's like a color temp mode. I don't know. Here's an all on mode, and adjust the personality of that way. But this is let's call this 6-channel mode, and we'll write that tonight. So I'm not going to want to analog write anything out to that LED pin, of course. I want to say pixels.setColor. You know what? Let's do. We're gonna start with the slightly simpler version, which is we're gonna ignore the intensity channel, and we're going to say set color. We'll just do it as if the intensity channel was always full, and then we'll go back and adjust from there. We'll do pixels.setColor. Oh, you know what I should do is copy and paste my my set all color function from one code base into the other, because I want to reuse that, because for the moment, right, in this first personality, let's say that we want all the pixels to be the same color, and then we can get fancy about it. Set color, actually we'll just use our built-in function. We'll say set all color red, let's see, DMX slave dot get channel value 4, DMX slave dot get channel value 5, DMX, of course, slave has a V in it, not a C. DMX slave dot get channel value 6. Yes, servo moves and set all color. Let's make sure this compiles. How have I? I've missed a capital V out here in get channel value. That's fine. Let's compile that. Pixels was not declared. Oh, did I not add a fruit? Oh, I should be declaring all of these constants and the object not in my setup function, but in my preamble here. Because otherwise it won't know that that object exists. There we go. All right, compiles. That's a good sign. Thomas is doing RGBW pan tilt. Yep, totally valid. And yeah, like intensity is not really required here. I think it might be a fun programming exercise to put it in. So right now, we'll be ignoring address 1. 2 and 3 are pan and tilt, and then color. So and also I should do in my setup function, I should do pixels.clear, so it starts off. Would be good. I'm also realizing I've sealed up this light and I'm gonna need to reprogram it, but that's okay. That is plausible. So turn the power supply off, come back to the table. You get to watch me do this a little bit. I mean, it's not in the dark for me, it's in the dark for you, but you know, the light show is the fun part. You've seen the programming of this before. We'll get down in there with our programming header. There we go. And we will upload our code using the programmer. Oops. Yeah, as often happens, there's something about the way that this programmer interacts with Windows 10. It often forgets that it exists. So you unplug the USB and you plug it back in. I take a sneaky sip of beer. All right, well that's good. So that's what it does when it starts up as it moves to home, and now it's freaking out because it's confused about whether it has DMX or not. But that's also to spec, so to speak. Make sure, so DMX start address is set to 1, so that's good. So now we can button this guy back up and then write a real quick bit of control software to do our ballyhoo and rainbow. And won't that be fun? Let's see. Get in there. All right, so that's closed up again. Of course, I haven't put the side cover on yet, but that will come in time. Let's take this out, and I'll turn the exposure back up for a sec while we break out the test jig that I've been using for troubleshooting the RDM library. I should say, writing the RDM library. Break that apart a little bit, but it's all Phoenix connectors, right? So it's really easy to move stuff around. I don't remember, this must have been the one I was using as a controller because it doesn't have an LED on it. But I think this will be fine. Yeah, so I'm just gonna pull a few things apart here. Some twofers and things that I don't need in this setup. So now I've got my other Demilight board here that I'm going to use as a transmitter and transmit to this other one, which will be a receiver. So let's pull up some transmitter code. We'll find it in the moving light folder. We will find it in multi-test. And we'll save this as a Neopixel test. We'll define some new offsets for our various data in our DMX stream. And just some casual frozen Jeff. Maybe I'll turn that Jeff off too. I know he makes everybody. I'll leave him there. It's funny, he's in this view. He's not in this view because I turned that one off. So when we're here, when we're in full coding mode, that's when Jeff looks most aghast at what's happening over to her screen left. Let's see. Oh, I think this is some sloppy coding here. I think const int red offset equals 3, const int blue green offset equals 4, const int blue offset equals 5, right? So the offsets from the given DMX address where the data for those parameters is. One light at address 1, intensities equals 255, let's say. We're not going to use it anyway. So we'll come down in here and let's see, where does this all start? Well, this will all be fine. Let's come down and build ourselves a Neopixel ballyhoo. So the pan and tilt should work just fine as is. What I need to do is invent some data for red, green, and blue. So let's just start with a constant color. So let's say for int I equals 1. Let's say I need some brackets here. Int I equals what I really want to do is do like a for loop in the style of Python where I say for each in red offset, green offset, blue offset, but that's fine. I'll just hard code it for the sake of testing tonight. For int I equals 3, I is less than or equal to 5, I++, DMX master.set channel value addresses I plus I, and this array here addresses can hold the address of multiple lights, so we could have multiple things ballyhooing at one time, and this is going to be set to I don't know, 50. Let's see, 50. Oh, maybe we offset these. Maybe we say this is 50 times I. So 150, 200, 250. So some red, more blue. Some red, more green, even more blue. So it'll probably end up being like a bluey greeny thing. I don't know, just some test code to get this thing up and running, and then we can play with it doing a rainbow after that. But I want sort of like the most simple base case. Let's upload that. Of course, gotta reset the programmer again. I don't know why it does that, but it's when I moved from a Windows 7 machine to a Windows 10 box when that issue started, so who knows. All right, so that's done uploading. So I can unplug this, and so now in theory, and we'll see, if I give this system power, we should get a ballyhoo and a constant color on these Neopixels. That's the goal. And if it doesn't, something else will happen, and we'll fix that. All right. Power. Oh. It helps if I plug the light in. Classic. Good, good, good. Plug the light in. All right, and power. I guess flashing lights warning. I guess this whole stream should have a flashing lights warning. Really, this whole project is supposed to have a flashing lights warning. Yeah, that's not as intended, huh? I mean, it's kind of interesting. But it's not... What's interesting, I don't know how much it reads over the camera, but, like, it is clearly still trying to do something of a ballyhoo, right? It's moving on average left and right. It's moving on average up and down, just with a bunch of herky-jerkiness to boot. Well, interesting. Wally on cocaine. Yeah, that was exciting, to be sure. Yeah, something's not right there. Well, okay, let's eliminate some really obvious like coding issue. Let's instead of setting the value in our loop there, let's set those color values for all time and not change them. Right, let's set them in our setup function. I don't think this will be the issue, but let's maybe there's something weird with how it's updating the DMX. Just to try it. Okay, that's programmed. Get power. I think this will be the same. Yeah. It does make me laugh. That's pretty good. But it's not ideal. So here's my thinking. So one thing that's happening is every time we go through our loop here, we are calling this set all color function. And when we do, we set the color and then we set the pixels to show. And the pixels.show function, which actually outputs the data to the pixels, turns off all interrupts while it's actually outputting the data, because that 800 kilohertz clock rate is so critical. And so that could be interfering both with the DMX library, which is interrupt driven. It uses the ISR that triggers when it receives a byte of serial data to ingest DMX. It could also, I guess it wouldn't be interrupting necessarily the servo functionality because that's hardware based. But so one thing that occurs to me, and this is not the final solution, but I wonder what happens if we just say don't do this more than, I don't know, 10 times a second. It's gonna be jerky, right? But I wonder if we'll see a jerky version of what it should be doing as opposed to an awful version of what it is doing, you know? Oh, Chris says, like it's cycling between colors each servo move. Yeah, something is, they seem to be interfering with each other. And this is not entirely surprising to me. There's a big old comment in the Neopixel library about how it disables. Well, that's not right. That's not right at all. It's kind of making a fun little song. But that's not right at all. Well, what? Well, that's unexpected to me. Let's cycle that programmer again. I'm just gonna reduce, I'm not gonna take you over there, but I'm gonna reduce that delay in each loop to 10 milliseconds, right? So only 100. So the right solution, and on the one that I'm sort of afraid to dive into, is to, although maybe there's a hook for it. What I was gonna say is, what we'd really want is for the color data to only be sent out when the DMX has finished absorbing a one packet of data. Like when it gets to the end of that packet, just call show color once, and pixels.show once, and then not again until the next packet completes. And that would be, it's either going to be a pain of modifying the DMX library, but there might be a hook for it. There might be an existing like call my function when you finish function. So we should look at that for sure. See, this is behaving like it doesn't have DMX. This is what it does when it doesn't think it has DMX, and that's weird to me. Like I've broken something else. So I'm gonna actually remove that delay and re-upload and see if I've broken something else. All right, uploaded, powering on. We should have disco again. Yeah, we don't. So, like some bit of wiring has come loose or something. Because it's not, you know what I was doing? Was uploading the device code into the controller, which doesn't help anything. Let's try that again. So I'm gonna first I'm gonna re-upload the ballyhoo code into the controller. Chris, is that what you were trying to tell me by plug the programmer in? Yeah, I was plugging it into the controller, and that's not how anything works. All right, so we'll upload the ballyhoo code back to the controller hardware. Now we gotta plug the programmer back into the device. All right, that one's on me. I'm probably just gonna leave these as two separate parts. We'll get the idea. Because I think this will probably not be the last time we reprogram this guy. All right, so now we can upload the device code to the device. Yeah, Chris, this is what the big red phone is for. It's the big red Jeff's being an idiot phone. You gotta call me on these things. I was just so delighted I could get Malort into my phone number. Malort, I think many of you Midwesterners know, is a really awful liqueur. Like a bitter, awful, miserable. Hey! Okay. That's better. Look at that. Not perfect, right? And having this, like, it's only updating at 10 hertz is not a viable solution. Yeah, no color change, right? The color is static. But that's good. Let's change the color in the, and that twitch at the end, of course, is also not good. We could fix that as well. Oh, I don't know. I don't like that. Why did it stop there? Ooh. Something is not right. Because it should just be being powered by its built-in power supply. Yeah, no smoke, but like it shouldn't make a difference when I unplug. It's like it's not, it's like its voltage regulator is not functioning, which is not great. But for the sake of tonight, I'm willing to press on. Yeah, it felt like something could be burning. It's not burning. I don't think. I don't want to burn out my programmer either. Well, let's set this controller up to do a color chase, because that's really what we all came here for. So what I'm going to do is steal a function that I have used before from Adafruit called wheel, which just really simply takes a value between 0 and 255 and converts it to RGB. Like it says, if you give it a value in hue, it returns a maximum saturation value in RGB, which is really handy for doing things that cycle through a bunch of colors. So, let's see here. So in our ballyhoo function here, yeah, so instead of setting, I guess I'll set the value manually at the top, but then immediately in the value ballyhoo, I'll do something else. I'll say color equals wheel. Let's see, how do I want to calculate this? I don't want to do a cosine function. I want it to do a loop here. So I'll say 255 times current time. So wheel is capitalized? Wheel is capitalized. Mod period, which is the number of milliseconds in my cycle. We'll just do, I think it's a 3 second color cycle. Yeah, 3,000 milliseconds. I think that's right. And I will say DMX master dot set channel value. And I think I have getter and setter methods here. Yeah, so yeah, so this is, I'm also stealing these from the Adafruit library to like take one of these color objects and decompose it back into its red and green and blue values, yes. And I only know these are here because I've used them before. So I will say set channel value addresses I plus red offset red color current color equals wheel red of current color. Let's make sure this compiles. I'm missing an include somewhere. Let's see. Channel value. Did I do a big bad typo? Yeah, channel value is no good. Thank you, Dave. And it's not liking this color definition, which is weird because I feel like, oh, maybe I need to do pixels.color. Maybe it's a, yeah. Pixels.color. Are the tunes still going for y'all? They're certainly not for me, but that doesn't necessarily mean anything. Oh, you know what? It's because I don't have the Neopixel library included here yet. That's why. Include library, add a fruit. Neopixel. There we go. So now maybe this is all academic. Couldn't find the color class because I hadn't told it to include the color class, and that makes a bunch of sense. All right, compile. Still have tunes? Oh, that's good. Oh yes, so still nothing on compilation there. Let's make a pixels object, which seems like overkill, but that's fine. Let's see where it errors at. Num pixels, sure. 7, pin 4. Yeah, so it errored in a different place this time. So now it's allowing me to use this pixels object to return color objects, which is, again, this is not, I'm sure, how it's meant to be done, but I will bodge this together for now. Let's make sure those are all taken care of. Pixels.color, current color. And I need a semicolon before current color. Weird. Like I have a parentheses error, except I don't. Current color was not, I have more errors. Do I have, is the wheel color included in the Neopixel library? No? No. That would be silly. Well, maybe we'll just do this all manually because I can't be bothered to figure out what's going on with this built-in function. That's fine. Be more instructive to write it anyway. And Thomas, I haven't forgotten your 16-bit dimming question. Well, I had for a moment there, but now I remembered it, and I will answer it. Oh, man. You can't even see my face right. I'm looking screen left at like a goober still, for all time, and that's fine. Okay, so DMX master dot set channel value addresses I plus red offset, and that's going to be 127 plus, and we're going to use a sinusoidal function to create 3 staggered offsets in our red, green, and blue values. So cosine current time plus period divided by num lights times I. Yes, there we go. So that is our red, and our green and our blue will be similar. Green offset and blue offset. And for each of these, we base not on the current time, but on current time times 4 divided by 3, and current time times 5 divided by 3. Is that right? Sure. No, current time plus, I'm just gonna hard code this because I'm a bad person, plus 2000. That's fine. Okay, compile. Numlights was not declared because numlights is not capitalized. That's fine. Compile. Numlights is capitalized the other way, and that's fine. I can do that. And compile. And I'm missing a semicolon. But there. Perhaps here. Perhaps I deleted one line too many. Yeah, it's compile. Yeah, so many compiles. Okay, we compile. It's good. Okay. Now we upload? No, of course not. We upload? We're uploading! Hey, good. Hey, it's my face. Chris is 3 hours later. All right, so, fingers crossed. We're uploaded. Unplug the programmer. Turn the power on. Oh, plug the light in. So not perfect, but yeah. Nice. Yeah, we got there. We got there. Three hours after we started. Some bad hardware. Some bad typing. Lots of good proofreading. Thank you, everybody out there. Lots of good moral support. We got there. We got Neopixels. We got a tasteful ballyhoo. That feels so good. Yeah, that's awesome. Cool. So, where do we go from here? I'm kind of thinking, well, we're closing on the end of the night. It's only so late any of us can stay up. But just as like a, so I guess I want to show, I want to do a quick investigation. Need some black tack inside. Ooh, let's put the other half of the of this thing on. Chris, I actually ordered a bunch of interesting lens modules from AliExpress today, some of which are like black and enclosed. There's, long story short, investigating new primary emitters for the Demilight because the ones I'm using are no longer on sale and very expensive. But there's lots of alternatives, and some of them are like monolithic enough that you can do like a 20mm 10-degree beam angle lens with a black housing that I think will be super classy. So that'll be fun. Yeah. Oh, we gotta turn some lights off in here. Hang on. We gotta have a bit of a party. Where's the switch for this one? It's this. Yeah. Yeah. Let's see if I can get it to. I'm trying to aim it at something. Oop. Hello. Oh, yeah. So it slipped out of the socket there. Here, maybe we'll just go full darkness. Oh no! Oh no! The camera! Oh no! The whole point of the thing! The camera! Oh man. Well, isn't that just about how man. It's something to do with, I think, the USB. Ha! Whoa, it's spooky in here. Boo. But this is what I was hoping. I hope you get like a colorful light show on my face, and it looks like we pretty much are. Hello. Spooky DJ light show in multiple colors. Yeah. Oh, it's so good. All right, let me turn a few lights back on so I can actually see what I'm doing. So, there's there's this. I guess we've been leaving that off, and there's this. Okay. So, let me open VS Code. Here's what I'm thinking would be the right way to. So right now we're getting around the fact that we were updating the Neopixel state way too fast by like limiting our total update rate to like 10 hertz, and that's okay. Like I don't think it's not moving much more jerkily than it was before, so like it's fine. But I wanted to see, as long as we, can, if, oh, there's advent of code again. Let's leave that behind for now. Let's open the JDMX library, which is what this is all based on, which is like I say, a fork of Concept and edX. I have not done that much work on it, but it's what I'm using to build the RDM code on top of. And I wanted to see, I feel like the library has, let's see here, on frame received. Yeah, so that's really what I want, is when the, when it's done receiving a frame is when it should update the Neopixels just once. And it's got a bunch of events in here for RDM events, like you say, when event on identify, when it gets an identify message, run a user framework. But the only one with the DMX slave is event on frame received. Oh, except this is probably what's being used, but, oh, mic crackle. Oh no. How is it now? Here, let me get my meters up. I can maybe see for myself. Oh, here, can I monitor myself? Ah, how is that? I mean, we've certainly got, the phone's for. I know we've got like servo motor noise in the thing, but how is the crackle? Oh, well, I bet you heard one just there, because I did. Yeah, ooh, sorry. Yeah, loose DMX, loose XLR connection. We'll do that to you every time. So sorry about that. Yeah, so like, as I was saying, I wonder if the proper thing to do is to override this built-in method called onFrameReceive, so that it only tries to update the pixels when it has a complete DMX frame. And when it does, right, there's going to be a mandatory at least 88 millisecond gap, or 88 microsecond gap before the next frame starts, because that's what the DMX spec says. And then you have the start byte, and then you have a bunch more data coming in. And that's an opportune time to like take a few a few microseconds and push the data out to the Neopixels, and that would be fine. I think that is going to be deeper down the rabbit hole than I can sensibly get into tonight. But I should at some point. Only because I think a lot of it is going to be me double checking the syntax of how you override this function, which is not going to be terribly stimulating, I think, to watch. Maybe educational, but probably more interesting just to look at the code base when I finally get it right. So I think just as like one more little fun thing to do tonight, let us implement a different personality for the... Oh, no. As one last thing to do, let's talk about 16-bit dimming. Since I don't have a... I'm going to turn this guy off just for sound's sake. Since I don't have a 16-bit dimmed device, Thomas, I totally didn't forget. Let's do this. I'll do this conceptually in a different way. Let us do this in VS Code. So, oops. Well, closed it. We will close the folder. Close folder. Close. Close workspace. Yes, that's right, because I had it as a different thing. So now, so let us say we... I'll take it back. I'll show you in the DMX code here. So let's say we had a 16-bit value. Yeah, Thomas, you're totally right. So in theory, you can use so the ATmega328 has one 16-bit timer, and you can use it to do 16-bit dimming. But the problem, I think, is that the default servo library also uses the 16-bit timer, and of course I need both channels of servo output. So I think without going to a different microcontroller, I don't think I can natively do 16-bit dimming without giving up servo control. I looked into this at one point, and what I'm looking for is the timer data. Yes, 16-bit timer counter 1 will allow for let's see. Could do a shift register cookie, could certainly do, or could go to an external 16-bit dimmer. I'm just saying, like, without adding additional hardware. I think I'm using all of the capabilities of the 16-bit dimmer that I have. Now, nominally, you can port the servo library to use an 8-bit timer, I suspect, maybe, but I think given that if you had the ability to order a servo that you could set its minimum and maximum timing values, I think it would be more feasible. But given the limited options for pre-scaling in the ATmega328, I think trying to hit, so like, a servo pulse, right? If the servo receives a pulse that's, 1,000 microseconds long, it's full counterclockwise. If it's 2,000 microseconds long, it's full clockwise, ish, because they're crappy, hobby servos. And doing a 16-bit timer with minimal pre-scaling lets you really hit those 1,000 to 2,000 values right on the nose, pretty much. Doing it in 8 bits, though you still only have 8 bits of precision across that range, but you're not really needing 8 bits of precision. You're needing to get a 1,000 to 2,000 microsecond pulse out of a 16 megahertz clock, and trying to do that in 8 bits seems challenging. Thomas is using 2 DMX channels, 1 coarse, 1 fine. Get that 16-bit resolution, then use it for my tilt axis. Sure. You probably just heard some more clicks, cause this time I kicked my audio interface. That would probably do it. So sorry for your ears, especially anyone on headphones. So Thomas, what you would do is something like this. So let's assume, for the sake of this example, that course is on DMX channel, DMX address 11, and fine is on address 12, for example. Just so we have something to work with here. So, no, I was trying to do a block comment. Oh, I'm so sorry. Get out of here. Single line comment. Yeah, there we go. We would say, let's say int, let's do byte course equals DMX slave dot get channel value 11. Byte fine equals DMX slave dot get channel value 12, right? To combine those into one 16-bit value, you would just do int, because by default an int is a 16-bit value in the Arduino environment. You could also say uint 16_t, right? It's sort of the C++ name for the same thing. Let's see, call it tilt axis. So let's call it tilt axis will be the name of this variable, equals course left shift by 8 places plus fine. See if that compiles. I won't upload it to anything, but yeah, for sure. So basically what you're doing, and I'll leave that on screen for a second while I get my portable whiteboard out, which I am delighted about, and I turn my exposure back up so we can actually see it, is we take our incoming course value, and it equals some binary 8-bit value, right? So let's say it's 0, 1, 0, 0, 1, 0, 1, 1, right? And our incoming fine value is some other 8-bit value, right? Let's say it's 1, 1, 1, 0, 0, 0, 1, 1, or something, right? And what we want is the 16-bit value represented by the two of those, or in other words, what we'd like is the tilt axis equals 0, 1, 0, 0, 1, 0, 1, 1, followed by your find value 1, 1, 1, 0, 0, 0, 1, 1, right? So that's what it means for us to be a 16-bit value. Is the coarse represents the upper bit, the upper byte of it, and the fine represents the lower byte of it. And so the way that we do this in code is we say, wow, these pens are so thick-tipped. TA equals coarse left shift, which is these two less than signs, by 8 places. And that says basically take this number and move it, literally move it to the left. And if you run out of numbers to give you, just append zeros to it. So this becomes this number plus 8 zeros on the end. So 0, 1, 0, 0, 1, 0, 1, 1. And actually, I take back a slight bit of notation that I had earlier, although I think it would be fine. So this becomes our 8-bit value followed by 8 zeros, 1, 1, 1, 4, 5, 6, 7, 8. And then really what we should do is a bitwise and instead of an addition, although I think it would work out the same. Bitwise and that with our unmodified find value, right? So our find value, if this is our new giant shifted over coarse value, our find value is still, if we align the places correctly, looks like that, 1, 1, 1, 0, 0, 0, 1, 1. When we bitwise and those together, anything in, these values are anded with, oh, no. We would want to do plus, I guess. I guess we'd want to OR it, is what I mean. I messed this up in my admin of code challenge the other day. OR, bitwise OR. So with 8 bits, we have 2 to the 8th. With 16 is 2 to the 16th. Exactly so. Yeah, so changing the coarse parameter changes your, in 255 large steps, and within each of those, or 256, you get 256 small steps within that, exactly. So if we bitwise OR these together, and if we stretch out this find value with zeros at the front here, because adding zeros in front of a number doesn't change it, right? Any position that has a 1 in either of these numbers becomes 1, and that just becomes the concatenation of these two values, right? So we get 0, 1, 0, 0, 1, 0, 1, 1, and then from the lower value, 1, 1, 1, 0, 0, 0, 1, 1, which is what we were looking for up here, right? We had basically the concatenation of those two numbers. And I apologize for messing up the operators here. It's coarse, left shift 8, or fine would be the operation that you want to do. And that gives you your 16-bit number. What you want to do with it at that point, right? Does it drive a... I think you're using steppers for your tilt control as opposed to servos, which is super cool, right? I'm using servos because they're the smallest option, but Thomas has a beefier solution going on, which I'm super stoked about. Yeah, that's how you handle 16-bit parameters. This gives you a 16-bit number, which is the combination of a coarse and a fine parameter. What you do with it is up to you. And yeah, NEMA 17 motors, it's 36 volts. Yeah, you've got some serious power there. It's sort of the opposite end of the precision and power spectrum from tiny boys down here. Yeah, super cool. Further questions that anyone has about controlling or things we might modify on the Neopixel version of the tiny moving light? I really enjoyed going through a lot of that, like how would you make a how pixels behave as if they're in groups. Like that was a cool divergence from plan there, Dave. It was fun to think down that alley. Similarly, like we're basically using that same logic to like make this tiny light behave as one large group of pixels. But we could also individually control each pixel if we wanted to have like an open face, flashy, Chauvet-y kind of fixture if we really felt like it. Yeah, I wonder, I don't know what this is addressed at. Maybe as a closer, we'll plug both of these lights back in and let them ballyhoo together, one in white and one in colors. And that can be the closing image, and we'll roll credits. And that feels pretty good. Let's see here. Now, I think this one's addressed at 13, if I remember correctly. So I'm going to have to modify the control code here just real quick. Let's see. So coming into our controller code, my addresses are going to be 1 and 13, and the intensities are going to be high and low, current time, loop. And of course, the additional parameters won't mean anything to the dumb LED, and that's fine. Chris says, looking forward to board 095 where you can do dumb LED versus pixel LED. Oh, yeah, for sure. Yeah, integrating some additional connectors onto that board so that stuff like this is not a matter. I mean, honestly, just additional 5-volt and ground ports and a couple of additional IOs will be a game changer there for sure. Nice. Oh, the TMC 2100 is Thomas's servo driver. Cool. All right, so that's uploaded. Ooh, Cookie, you are working on chain motors. Oh, I'm so Cookie is the one who made like the 3D printed truss model. I don't know if Cookie, have I shown those on stream? I printed a few. I don't know where they are. I'm so sorry. We'll break them out on the 10th when we do our big kickoff. But I've been thinking for a while about doing scale chain motors, and I haven't gotten anywhere, and now I'm just going to print your design when you make it. Because I'm super stoked. I actually went down as far as like trying to find scale welded chain from AliExpress. Super hard to find. But there was some, but I'm super excited to see what you cook up because I love the truss kit that you put together. It's awesome. Yeah, January 10th is gonna be we're gonna have a good old time. I think we'll have some fun at least. Let's see if this. All right, so maybe I was wrong. So the thing about jewelry chain is like it's not welded, right? Or it's not secured, and so I would worry about it breaking apart. Well, this light's not moving. Ooh, fishing line. Yeah, that sounds like clear monofilament stuff. For strength, that makes a ton of sense. Don't deal with tangles at scale. Yeah, that's fair. Let's see. So this is not moving at all. I'd really like it to be. Hang on. Let's just reflash some firmware. And you know what I'm gonna do? I'm gonna just give it this exact same Neopixel code and make it address 1 because the Neopixel code is ignoring. Oh no, I can't. I gotta give it the original code. Here, we'll come over here. You can look at Sideways Jeff just a little bit more Sideways Jeff for y'all. Because I know he's been a big part of tonight's work, and I really appreciate him. He's really stepped up in this time of crisis. So thanks, Sideways Jeff, for your sacrifice. Chris, I didn't think I had to. I thought this unit was still programmed as just a basic unit at address 13, but I guess I was wrong. So I guess I could show you. I'm currently plugging the programmer back in. Oh, except there we go. Not entirely encouraging. The power LED, the 5-volt rail LED on that light is not staying lit. As if the programmer is not able to power the board. Which implies some kind of issue. I can lift 2 pounds with a single motor. Yeah, steppers would be a super powerful way to do. What are you thinking for motors currently, Cookie? Just out of curiosity. Yeah, something is wrong. Something is wrong with this unit. I thought this was a good and working one, but apparently it is not. Because the 5-volt rail is not even staying on. Which maybe is something as simple as a bad solder job on the regulator. But could be something that would take us another 3.5 hours to fix. So I propose, in contrast to what I said earlier, the way we'll end tonight is just enjoying a tasteful little RGB ballyhoo inside the mini moving light. So this is going toward, it's not going to be hitting maximum brightness, it's going to be tracing a path of maximum saturation, right? But here, let's go to spooky mode one more time and just give you a sense of, so one of the reasons like I haven't super pursued this as like a primary option, although it's not unbright, and it's hard to get across relative brightness on camera, of course, right? It produces a decent amount of light, but it's, you know, a fifth as much as what is currently a current limited version of the emitter on the white version. And so it just feels like it's in a different universe of use case. Although this is very fun, like one of the warm white Demilights could serve as a lighting source, and this one is more of eye candy at this point. You need many of them to actually cast some meaningful light. Yeah, there's just haunted things happening behind me here. There is an owl bear back there, but it's unrelated. So yeah, so this is a fun project and a fun toy. You know, RGB and RGBW primary source control, of course, would be like primary lighting would be an awesome long-term goal. But for the sake of like proving this is possible, and who knows? This is my imagining what the use case for these things are. If your goal was to make a little tiny light lab with multiple colors of these things, and it's all sitting on a tabletop, maybe this is plenty of brightness, right? I'm trying to get better about not imagining and presuming that anyone will use them, but like why limit the possibilities just because it's not what I'm imagining but I would use these for, just to prove like that it's possible, and I should put some more holes in the circuit board, some more pads, so people can do interesting things by it. 100-watt RGB LED. Wow, that's so much light. I have a couple of 100-watt cobs up here somewhere from AliExpress that I played with ages ago, but as you can tell, in the meantime, my interests have tended just a little bit smaller. But yeah, it's a fun time all around. Yeah, Thomas's light is going to be, demi is a Greek prefix, Latin prefix. It could be like the kilolite. That's not pronounceable. The Yakta light. I don't know. You think of your own name. I'm stoked about it. I think that's where we call it for the night, y'all. I think this is, here, I'll put you on the fun view, because this is really the outcome of all of this. This was super fun. Just to like prove up that it could be done. And, you know, people always say that like the troubleshooting parts of these are interesting and people learn things. I hope that's true, because there certainly was a lot of that tonight, including that stupid frickin' Pro Mini that was hosing us for the first 20 minutes of this experiment. I'm still steamed, but I'll get over it, I think. Yeah, this is a good old time. Happy holidays, y'all. Happy New Year. I hope you're staying well and staying warm out there. Yeah, that's all I really have to say. We'll be back next week with more Raspberry Pi stuff. Got some Raspberry Pi presents for Christmas. We'll be looking at, so this phone system is actually running off a Raspberry Pi, as is the micro arcade that I was gifted. So we'll be looking at how, working with Raspberry Pi distributions and some basics of like the bash terminal, and the Linux command line, as it were. If you are a Mac user, that's pretty relevant to you, because a bash-like shell is built into Macintoshes as well. But yeah, we'll have a fun time. That'll be next Sunday, and then 2 weeks from now, by the 10th, we'll have the Demilight files online. There'll be the jeff.glass/Demilight, and we'll have a new page that links to from there with all the build instructions, at least as they exist. And then so we'll have a big old party and show off some things. If you're building fun things, Dave, Thomas, Cookie, if you want to like, you know, show off some pictures or some videos, or Skype in, or I don't know what we would do, but like if you want to show off some stuff, that'd be awesome. Like it seems like a fun time to just like be like, hey, here's all the cool things. Etsy store for the PCBs, probably not yet. Probably I want to get the files out there in a state that like you could build one with some work and then get to the next step before I like, you know, sell them to people. Maybe. We'll see. Maybe I should just take the leap and get out there. Thank you, Dave. Yes, happy to have, hopefully 2021 would be, you know, and some theater work coming back would be good for all of us. Yeah, be safe, wear a mask, wash your hands, stay hydrated, get some sleep. I'm thinking of all of you. Yeah, send me something, Thomas. Send me whatever you have. The whole point of January 10th is like, I'm going to try and get out there what I have and just trust that people will make good things with it. Yeah, we'll just have a great old time. Be well. You're all great. Love you, nerds. Subscribe. If you have questions, comments, issues, concerns, best place to find me is on Twitter at JeffersGlass, or you can call me on my phone. There is a voicemail set up. I don't know what it sounds like. Maybe you'll find out. 815 Omalort, and I will see you next Sunday night. Smooth as butter, like the rest of the stream. Good night, y'all.